I welcome you all to INNOG6 being organized by ISPI. This event shall be a regional forum to discuss issues and innovative technologies of interest to ISPs, network engineers, educators, trainers, technology decision makers, and the data operators in India. We look forward to welcome you all in this 4-day event, which shall include 3 days of a workshop and 1 day of conference, which is it being today. INOG provides a venue to share and learn from each other, thereby fostering greater collaborations at the working level. And with that, I would now be requesting Mr. Rajesh Charya, President of ISPI, to please come on stage and deliver his welcome note. Can we have a great round of applause, please?
Good morning, everyone. Seeing you after 3 years, and the pandemic has just derailed us a lot, but taught us a lot about the online meetings. But what I was just discussing with a few of my friends, that online meeting doesn't give so much of energy between each other that our meeting is getting fruitful. On behalf of INOG Group, and on behalf of ISPI, I welcome you all to this INNOG6 event. Today is the conference day and rest of the 3 days are the workshop day. Today our program unfortunately is clashing with the Prime Minister's program, which is going on in the Vigyan Bhavan, and lot of ISPs and the technicians are also there. But anyway, this is up to 1 o'clock. After 1 o'clock, all the participants will be shifted over here for attending the rest of our conference. I welcome Professor Hujur Saran, Dr. Girish Saraf, Mr. Arnold Nipper, and Mr. Vivek Nigam from INNOG6 to this conference. And I will request all these gentlemen to be on the stage for the lamp lighting, please.
Now we are having our auspicious lamp lighting ceremony to invoke Goddess Saraswati, the goddess of knowledge. We have on stage with us Mr. Vivek Nigam from INNOG6, Professor Huzur Saran, Dr. Girish Saraf, and Mr. Arnold Nipper. And with that, I would now be requesting Mr. Vivek Nigam from INNOG6 to kindly stay back on the stage and deliver his insights.
already loaded you? I don't see it. Can I put it in with this? It's not that one.
It is your
उल्टा.
खाली है खाली है
I think हम लोग लोड कर दिए. We'll see if
हाँ हाँ
this one. Click up next. Left, right. Good to go. Just left, right. Okay. Pointer right only. Okay. Thank you, Rajesh. Good morning to all of you. My name is Vivek. I work at INNOG, and today I'd like to talk to you about RPKI invalids. And the reason I've chosen this topic is because a high percentage of RPKI invalids in the INNOG region are associated with IPs that are distributed to networks in India. So I'll talk about what these invalids are, what problems they're causing, and what we're trying to do to address this problem. So RPKI is the framework that is used to make the association between resource holders, such as INNOG members, and their internet number resources. And then using this framework, you create something called a ROA to show your routing intent. So through this ROA, you specify which ASN you have authorized to announce your prefix. Using the max length, you specify what level of deaggregation you have authorized the ASN to do, and so on. And then once you create these ROAs, other networks can consume this information and do something called route origin validation. So they compare what they see in BGP against what they see in your ROAs, and if the details match, they flag those announcements as RPKI valid, which means everything is good. But if they don't match, they flag it as RPKI invalid, which means there's a problem, and they drop those invalid announcements. So if you go to this website, you can see the list of all the large networks which have already deployed route origin validation, as well as other networks which are in the process of implementing it. So if your network is originating invalid announcements, sooner or later, this is going to be a problem for you because all these networks are dropping those invalid announcements. Now, RPKI invalids is not necessarily a bad thing. The whole reason you create your ROAs is to show your routing intent. And after that, if what you see in BGP does not match your routing intent, RPKI is supposed to mark them as invalid. But the problem with these invalids is there's no way for operators to know if an invalid is caused due to, say, a route hijack, or if you have created the ROA incorrectly. And for that reason, they drop all invalids. So if your invalids are caused due to an incorrect ROA creation, it's obviously a big problem, and you need to fix it. So at the moment, there are some 1,700 RPKI invalid announcements associated with IPs that INNOG has delegated. And most of these announcements, almost 1,300, are due to invalid max length. So this indicates that these are probably not hijacks, but more likely caused due to the incorrect use of the max length attribute in the ROAs. And over 800 of these invalid max length announcements are associated with IPs that are distributed in India. So for some odd reason, this problem seems to be more prevalent in operators in India. So here are some stats. If you see AS18101, they are currently announcing over 400 RPK invalid announcements due to invalid max length. AS9498 has some 250 invalid announcements. So these are big networks, and it's going to start causing some problems for these announcements. So to address this problem, we have released a new feature called ROA pre-validation. So this is the form we use in MyPinic to create the ROAs. And previously, once you completed this form and you submitted it, we would just publish these ROAs based on whatever information you entered in this form. But now when you submit this form, we do something called a pre-validation. So if we detect that the ROA you're trying to create or delete is going to cause an RPKI invalid, we will alert you about it so you can then edit those ROAs and then create the correct ROA so you end up with the RPKI valid state. And to address all the existing RPK invalids, we have something called the routing status alerts tool. So if you're an APNIC member, you simply log into Dash with your MyPinic login, and if we identify any RPK invalid announcements associated with your IPs, you will see it in this tool here. And then if you click on one of those alerts, this is where you'll see the details of what is causing that RPK invalid. So if it is caused due to an incorrect ROA creation, you can then promptly edit that ROA and then fix that invalid announcement. And then once you have cleaned up all your invalids, it's probably also a good idea to subscribe to the ROA alerts filters. So this way in the future, if you change your routing but you forget about your ROAs and that causes an invalid, we will send you an email alert to make you aware of that invalid so you can promptly fix that invalid ROA. So now that we have these proper tools to help you create and manage your ROAs, the first step in securing your route is to actually create these ROAs. So only a few years ago, less than 10% of all the announcement in the APNIC or in India had a valid covering ROA, and now this number has jumped to over 70%, which is fantastic. It's almost double the ROA coverage compared to rest of the Asia Pacific. But there's still 30% of routes in India which don't have a covering ROA, so they are open to potential route hijacks. So if any of you are APNIC members and you have not created your ROAs, please do consider creating them now. And creating the ROAs is very simple, and we have streamlined this process even further. If you're an APNIC member, simply register for MyAPNIC, enable your two-factor, activate your RPKI engine, and then publish your ROAs. This whole process takes less than 5 minutes. If you need any help, talk to me, get in touch with the help desk team, and help us secure all the routes in India. So that is a very brief insight from APNIC from me. Are there any questions? No? Oh, I see a question there.
Gaurav Kansal this side. So the stats which you have shown is only for the members who are a member of APNIC and not of IRIN, because in India the IRIN members numbers are far more greater than the APNIC members.
Thank you, Gaurav. I anticipated that question, so you're right. These invalids are just for APNIC direct members. The last time I checked, I think there might be about 200 invalids associated with IRIN resources, and oddly enough, most of them are not due to invalid max length. They are invalid origin AS numbers. So it looks like when IRIN members change their routing, like they change their upstream, they forget to update their ROAs, and that's what is causing those invalids.
So can IRIN members use this your service of APNIC for managing ROAs? Because as per best of my knowledge, IRIN is not providing any of these services.
That's right. So at the moment, this tool is only for APNIC members, but if you think IRIN members should also get access to it, happy to take that feedback and pass it on to our product teams.
Okay, thank you.
I see another old friend.
Yeah, thank you, Vivek. It will be good if you enlighten the current procedure for updating route object of IRIN also.
Proud.
how they are handling, if Nixie is present here, or you can enlighten, so that the Indian customers who are the IRIN member can know how to go about it.
Okay.
Thank you.
It's probably best for Erin to answer that question, but as far as I know, Erin don't have a portal right now to manage these updates. So if you have received your IPs from Erin, you have to email the Erin support team. If you're trying to create a ROA, you just have to specify the details of the ROA, what's your prefix, what's your max length, which ASN you've authorized, and then Erin use this MyPinic portal to register those ROAs and routes on your behalf.
Vivek?
Anurag.
Hi. Anurag Bhatia, Hurricane Electric. One quick point. I'm not going to bombard you about the iron inefficiencies. I think people are pretty much aware of that. So there are many NIRs under APNIC apart from iron.
Yes.
Are you aware of any of the NIRs who have implemented creation of ROA on their own with a portal, a member service portal-like thing which APNIC has?
Yes, quite a few of them have.
Can you name a few? And it would be just good to get in touch with them.
Well, JPNIC, for starters, they were the first to implement this. If you're a JPNIC member, you can do it. I think CNIC, IDNIC are also doing that now. And most of the others are in the process of implementing it.
And do they integrate, how they manage the IRR part in that case? Do they integrate IRR-related APIs with APNIC as well?
No, so only APNIC is using this interface, which use this abstract model to create ROAs and IR together. For all the NIRs, it's a separate process. So you separately create your ROAs, separately your IRR.
Okay, thanks. And about the invalids, I think numbers are bad specifically just because of two large operators, one starting with the name T and other starting with the name A, because they move prefixes within their companies quite a lot, and somehow
Yes.
this move of prefixes is not in sync with the ROA data. So
That is very right.
That's the reason for the Gaurav's point. So IRIN is much more clean because the operators are much smaller. They are not really moving prefixes within ASNs.
You're right. And some of the invalids, even though they're due to origin AS, it's not a hijack. It's because they have multiple ASs and they just created with the wrong one.
Hi Vivek, Rajesh Charya. I'm just seconding the talks of the Anurag as well as the Gaurav. Like the NIR are the part of the APNIC. So whether you cannot force NIR, the local NIRs, to implement this ROA into their system, because otherwise in 2012 the IRIN was started and today is 2023 and still we are lagging behind. We are talking a lot into the IRIN about implementation and they are saying we are in process. But in this IT time, how much time they need for implementing this ROA for the benefit of the IRIN affiliates?
Yes, and that's a very good point. And the issue with that is we can't force the NIRs to do anything because there's no policy around it. We can only support them and encourage them. But at the end of the day, if, say, IRIN wants to run their own RPKI engine, they need to have their own engineering team who will set up the self-hosted RPKI. So they need to commit to it. And we have our product teams who can help them, but we need them to take the initiatives and do it. So the only way we can encourage this is if more members of IRIN, request this feature to Nixie saying that can we get this portal so we don't have to do it through email. So if there's requests from their members and support from APNIC, I think we can get over the line.
Anyway, the services of APNICs are getting degraded because indirectly we are the part of APNIC.
Absolutely. So I totally concur with your thoughts.
Thank you.
Okay, if there are no further questions, thank you for listening.
Thank you so much, sir. And with that, I would now take this opportunity to invite Professor Huzar Saran. He's a professor in the Department of Computer Science, IIT Delhi. He's also currently the head of Bharti School of Telecom Technology and also coordinates the Center of Excellence in Cybersecurity at IIT Delhi. Can we have a great round of applause for Mr. Saran and I request him to give his presentation now.
ये मेरा नहीं, मैं आपने नोट किया हुआ होगा शायद। एक मिनट, ये मैं हाँ मैं ले आया था, जस्ट टू बी ऑन द सेफ साइड। दिख रही है इसमें? क्या खाली दिख रहा है? सिल्वर वाली यूज़ कर लो। देखो
कॉपी कर रखी थी हमने ऐसे इसमें आपकी।
दिख रही है ना? फाइल का दिख रही है। तो कुछ और ही है। हाँ देखो, इनॉग प्रेजेंटेशन में देखो। ये वाली है नहीं, इसकी नेक्स्ट। ओके, it's not come yet. इधर नहीं आ रही है। Okay. So thanks and welcome to IIT Delhi, all of you. So as mentioned, I head the Center of Excellence in Cyber Security and Information Assurance, and also the Bharati School of Telecom Technology. And so I'll briefly tell you about these centers. I think we'll just take 10 minutes to just introduce those. As you know, cyber security is kind of important. Even the discussion we were just having, Prashant was leading. What is the need for all of this RPKI is because people were spoofing BGP, right? BGP was not designed for security in the first place. Everybody was trusted originally, and then we had to put in all this thing. There were so many different attempts, and now ROA is one way of doing it. Everybody is supposed to publish who you should be advertised through, right? Which was a little simpler than trying to do a full BGP sec with a full sort of auth authentication, cryptographic thing. So you have to go in and add cryptography, just like you did with DNS also. DNSSEC also the same story. Even with email, so many things have happened, DMARC, DKIM, so many things we got added for security. So if you look at it in the internet community, security is a very, very important piece, right? And it is probably drawing a lot of attention and a lot of effort, right? Especially when you're trying to retrofit it in. And so of course, IIT Delhi set up a Center for Cyber Security about 10 odd years ago. And initially it was just doing some low level, it was doing some research and also some manpower training in a limited way. Objectives are obvious, I will not go much into it. The slides are there for anybody to see. To train professionals, to foster cutting edge research, to collaborate with industry and other academies, to do community outreach. This center is basically a small center, but it actually encompasses people from all these different departments, computer science. As we know, cybersecurity is a multidisciplinary field. There is the management aspect of it, the mathematics, cryptographic aspect of it, the signal integrity aspects of it, and things like that, where electrical engineers come into the picture. Computer science, of course, is part of it. So in our case, Department of Management Studies also is very active because a lot of the issues about critical infrastructure protection, you know, all this talk about how electrical operators are getting hacked, right? Suppliers are getting hacked, and what processes they should have, how to deal with threat from within your organization itself, from your supply chain, from people you hire as system administrators from third parties, your ex-staff who get disgruntled and walk away from you, right? All the social engineering attacks And some of the social engineering attacks have now become even more and more dangerous because people are using ChatGPT to generate the mail inviting you, that making it even more convincing, right, and having a higher success rate. So these are all challenges. This is some of the research that our masters and PhD students are doing. Security using game theoretic approaches in mobile networks, data integrity attack detection, smart meters, false data injection in smart meters. IoT is a big thing and it's being applied in all of these places. Smart city, you see so much talk about it. But if you don't have data provenance, same issue here. Some meter reading got done, how do you make sure all the way up it is accurate, right? Just like with routes. So either you put a very elaborate cryptographic framework there, but it's not easy to do that. It's too much overhead of that. So what do? So there are a lot of these kinds of things which are part of the research agenda within our cybersecurity. We also recently, a couple of years ago, launched the Masters in Cybersecurity, MTech in Cybersecurity. Again, I will not go into the details, but we do offer this course now. We have international collaborations. When we got founded, we started a collaboration with the University of Nebraska, Lincoln, then multiple collaborations with Estonia, with the University of Maryland, with SUNY Buffalo, with Kyushu University, Japan, and for example, we have one major project with Kyushu University, Japan, and under the Indo-Japanese things on security in the Internet of Things space, right? And how to create secure execution environment, security in connected devices in 5G. So we were involved, and this is something where both my role as Bharti School head and my role as COE sort of collide. So we in Bharti School, and I'll talk about it, did a major initiative on 5G along with other institutions. So we set up in the previous 4 or 5 years a 5G test bed. And now we are also looking at beyond 5G. I'll talk about that briefly. And one of the aspects there is security in all these connected domains, how to do authentication. As you know, all of present day financial security is based on your OTPs at the end, which is of course depends on your operators who are doing same SMSs, but the SMSs are going unencrypted, right? So that itself is a danger. But as you go to 4G, 5G, and so on, all this will be, so your sort of one root of trust in some sense for the financial community is your mobile number and your ability to reach you with secure messages on your mobile number. That's how you validate, where the secure keys and so many other things are doing the same kind of thing. So this aspect of security in 5G/6G kind of scenarios, where even the legacy infrastructure, GSM kind of infrastructure will not even be there. How to do it? It will be all internet-oriented kind of pure data networks really, right? So there are a lot of interesting problems there, which are part of our research that we do within the institute on these things. This is more detail of on the security in the Internet of Things space. As I said, 5G metering of all sorts, pollution monitoring. These are obvious applications, at least in the Delhi area, for some of these IoT things which IIT has been working on. And of course, another important area is the whole automotive area. You know that within the automotive, there are a whole bunch of computers and they are all interconnected together, today using the CAN bus. But in future, these vehicles are now also connected over the internet to control centers, getting continuous updates of software, patches, whatever. And in view of that, again, sort of the network security and cyber security in general reaches into cars, and there are a lot of issues there itself that I'm sure you're well aware, including the fact that if you have a car key, a remote car key, people can very easily hijack it, right? There's an attack, one of my colleagues, Professor Vireshwar, works on that. He showed how you can attack that, okay, you went to the restaurant, your key is there. They'll put a radio relay there and a radio relay near your car, and you'll unlock your car without you realizing it. because whatever signal your key is generating will be picked up by this radio relay and relayed to near the car, and there they will press the unlock button on your door, and the car will unlock because the signal gets relayed. You are not near the car, but the car has got unlocked. So these are just illustrations of the fact that how, as we are using basically radio or networking technology for all these devices, security becomes a very major area. And that's one big area of research within IIT Delhi, in our COE in particular. So now let me briefly talk about the Bharati School of Telecom Technology and Management. This was founded by the Bharati, with support of funds from the Bharati Group around 2002 or 3, I'm not very sure of the exact date, but around 20 plus years ago. It has been running master's programs, MTech, MS, PhD, and MBA programs in telecom management. And has been doing a lot of funded research in from wireless technologies to telecom to networking technologies, the entire gamut. Just want to highlight a couple of recent projects. One is a major project that we had, and I was heading it at IIT Delhi. There was a 224 crore rupee project which was funded to a bunch of IITs, including IIT Delhi. IIT Delhi's component was 30 crores on setting up a 5G test bed. And that is what was sort of funded 4 years ago, and it sort of now it's in a maintenance mode. And that looked at issues like security for 5G, IoT, narrowband IoT based applications, visual light communication, massive MIMO signal processing, mobile edge computing, which is another area of good interest because of AR, VR and all those things. If you want very fast response, you don't want everything go all the way to the cloud. And then of course, everybody is worried about climate change, how to do 5G and all this stuff, and all of networking actually more efficiently, more energy efficiently. So these are some of the topics that we looked at in that project. And now we are currently doing another project with the Ministry of Electronics and Information Technology in partnership with the other institutes again for almost 100 crores on next generation wireless research and standardization for sort of beyond 5G going up to 6G, right? So this is the work that has been going on in Bharati School. These are, as I mentioned, 5G, IoT, sensor network for data analysis. Again, I will not bore you with all the details of the slides. I'm just putting them up for your general sense of the kind of things we do. And this did and do. As I said, for edge computing, sometimes the processing can be done locally at the edge. So edge processing for IoT applications as well as for AR, VR, that also we are doing. Then energy harvesting. So that here you see when you do sensors, if battery life becomes a big issue. But can you leverage strays, wireless, and other energies to elongate your life so you can harvest energy? This is another area which is of active work. Professor Sudesh Day and others within our center look at that. I already mentioned about the security and connected devices in next generation network. Areas include key management, authentication mechanisms, provenance algorithms, data provenance algorithms as I mentioned, state-of-the-art adversarial models to understand what kind of attacks can happen, and of course demonstrations using some testbed for student and other participant training. We also for a while had in partnership with Ericsson, 5G testbed from them, a center of excellence on 5G innovation, funded by Ericsson. That was for 5 years. It completed a few months ago. So we explore things like that. We are work with. So I just want to highlight that from the perspective that we do work. We are very happy to work with the industry, and it doesn't have to be just Bharati, right? On many of these kinds of areas. For example, a project we are just doing recently is with Meta on backhaul connectivity for example, for 5G and other areas using 60 gigahertz spectrum. So we are setting up a small test bed here in partnership with them and Cambridge Networks on Cambrium Networks, I believe, on using backhaul. Of course, 60 gigahertz, the spectrum licensing decision is still not made within India yet. But with an experimental license, we are trying to demonstrate that that is also a viable choice. As I said, in the 6G kind of effort that we are making, the next generation thing, again, there's a lot of focus on edge computing. We have even for AR, VR, we even have a demo. Professor Brajesh Lal is handling that, on how you can use robotic control using haptic devices. And we have demoed that in IMC and other places also recently, using edge computing to do all the computation, because you can't really, the control delay loop has to be tight, right? Another area we are looking at is 5G broadcasting. See, if you want to broadcast, that's another aspect. Because, the default is everybody is using OTT platforms such as Netflix, YouTube to watch a lot of video over the wireless also. If the popular things like the latest cricket match can be broadcast rather than everybody drawing their own stream, it could be more efficient for the network operator. So broadcast technologies in the 5G, there is some effort on that standardization effort, and we are also involved with that. Security I already mentioned, and then physical layer technologies to enable ultra reliable low latency communication. These are some of the, and some stuff on panel, antennas, etc. also. This is more detail about the mobile edge computing platform that we have. And it's ETSI compliant, so we built something that is around the line that, ETSI also has a standard around mobile edge computing. And we are working with that and extending that. And then for broadcast, again, there is more detail here. I will, given the time available, I will not go deeper into it. Right? But again, there is work that has been happening internationally also, and we are working along the same lines and working and trying to work towards standardization of 5G broadcast. Other kinds of things that come up is when you're doing network slicing. So again, there is a huge amount of how do you protect one slice from the other. Then you are trying to do all the cloud kind of security techniques in your network slicing, your local edge compute center where you're doing all of the natural network function virtualization. And then security in the aspects of if you're doing remote control of remote aerial vehicles and things like that, or remotely driven automotive vehicles, things like that. Then again, security becomes a very important aspect of that. So again, I'll skip the details here. The slides will be available if somebody wants to look at it in greater detail. And some of the work, you can always connect with me and I'll connect you with the right person if you have interest in any of these kinds of topics. So I'll stop here. And that's sort of the big picture of where IIT Delhi in the various schools, which I do happen to be associated with, is doing work which is related to the kind of efforts you guys do in INNOG. Any questions?
Thank you so much, sir, for your address on cybersecurity. With that, we move on to our next speaker, and I invite on stage Dr. Girish Saraf. Can we have a great round of applause, please? He's the founder of the Vegan Systems, and he would be delivering a presentation on the network automations.
Thank you, everyone. And happy Gudi Padwa to you. So let me start. And firstly, let me thank INNOG6 for inviting me here. I'm going to talk about network automation and what we are doing at Vega Systems. So let me start. Network automation is transforming the networks. In terms of, say, building productivity, building scalability, or just the responsiveness and the customer satisfaction, improving those. So network automation is becoming more and more important, particularly with 5G and machine-to-machine communication. So I think last edge is getting cut. Okay. So as more and more OTT services, 5G and machine-to-machine communication is coming on board, the network sizes are becoming very big. So you need scalability of the order of about 5x to 10x compared to the earlier versions. And this has to be very cost efficient because the network budgets are not going up. And from that perspective, automation is the need of the hour. And there is a criticality in terms of network automation tools, which has been recognized by Gartner. And it is estimated that in next 5 years, the network automation market would be of the order of $30 billion globally. So it's a large opportunity. Essentially, what we bring is, direct execution or zero-touch processes, improving the customer satisfaction rating through responsiveness and issue resolution, and lastly, reducing cost and operational efficiencies. Let me briefly introduce you a network automation platform, and then I would talk about some of the use cases that can be handled. So this is a network automation platform that Vega has built. By the way, just to begin with, Vega is started at IIT Bombay, where I was a professor. So we have a lot in common with IIT Delhi. Many of the Center for Excellence in Telecom, etc., are also common. And this is an offshoot of that. So all these activities, what Professor Saran mentioned, similar activities are going on at IIT Bombay. And Vega is an offshoot of IIT Bombay. If you look at our automation platform, it has interfacing with 3 types of systems or existing devices. One is interfacing directly with the network devices through various technologies that may be there. Then interfacing with your existing OSS, BSS, and CRM type of systems that are there. And lastly, your opaque applications, which are through the GUI interface, or often called robotic process automation. So we encompass all these 3 types of interfacings, build a intelligent control and control overlay on top, which is for logic building, decision making, and workflow capabilities. And the way automation platform works is it has an existing library of rules. And it invokes different rules based on whatever is the logic that is required, workflow that is required. So essentially, the delivery does not require new software writing. And you are combining the existing capabilities. It is more like a Lego building blocks you are putting together to build a solution. So that way it is efficient, and the software modules or rule sets are already optimized in terms of delivery. So what this delivers is that it's a versatile platform supporting multiple network technologies, multiple vendors, different operations processes, and customized workflows. how does this play role in your network operations? Various kinds of processes can be automated, whether it is a service activation, orchestration, provisioning, or what is often called fulfillment part, or it could be a troubleshooting and root cause analysis when there are issues, say typically the L1, L2 support or more sophisticated analysis. Also, if you want to have a large network and policy intelligence and policy compliance, audit and change management, or some complex analysis, as well as certain, upgrades, patches, etc., that have to be rolled out across large network. So these are various capabilities that automation platform can bring. The key aspects are it's a versatile in terms of multi-vendor, multi-technology, multi-services, and it has dynamic information gathering capabilities in terms of your existing OSS systems. It also allows you to build intelligence. Your logic, every network operator has a different process, different logic in terms of network engineering. So that means any process that needs to be automated has to be customized for that. And this brings that sophistication in terms of handling complex workflows and processes. And lastly, it provides flexibility in terms of the customized delivery, as I mentioned. So what this enables is that you can bring automation to different types of processes. And it could be a gradual process in the sense that you could only automate the service orchestration piece, or you can do a troubleshooting and network issue resolution type of automation, etc. It has real-time information processing. That means it is aware of the current status of the network to the last detail, and it is capturing information for all your existing systems. So it is an overlay. It is not trying to replace any of these, your existing systems, but essentially combining various knowledge processing and the logic in terms of network engineering into a smooth automated workflow. You can put in a AI ML engine on top to have a closed loop automation as well. So as networks are moving towards automated or autonomous networks, then you can, so essentially the network automation system provides you the eyes, ears, hands, and legs to operate on the network, and AI ML can come on top of that in terms of closed loop autonomous system. So, essentially you are building intelligence and logic into the automation platform. And what we have seen that specific automation processes, you can get up to 80 to 90% saving in terms of time, effort, cost, etc. So let us look at how we interface with various systems. I have picked 4 different network domains. One which is IP MPLS domain. Second is optical transport or DWDM, this thing. Third one is FTTX or GPON networks. And last one is your RAN. And then there are various kinds of interfacing technologies, right from your SNMP and SSH to all the way to, telemetry, Kafka, Netconf, Yang, etc., etc. So you have a real-time data mediation and build your automation on top of that, interfacing with your various systems. Let's look at few use cases. First is a troubleshooting automation in a managed services NOC. Essentially what you are doing is, this is a workflow which the L1, L2 support team follows in a managed services NOC, a specific use case that we have taken. And there are a set of systems and applications which are existing. First is, a web application which is essentially querying the various customer sites and proactively capturing which sites are having issues or down, in terms of connectivity, etc. After that, there is a step in terms of can we check the last mile connectivity and performance, because typically last mile is where many trippings occur. If last mile is okay, then you go back to the detailed inventory in terms of your circuit in the back end, whether it's a carrier Ethernet or SEN type circuit or DSL circuit. There could be various options there, and do a detailed drill down into the back end circuit, and finally put together all the information and proceed to the interfacing with the ticketing. Idea is now you have entire diagnosis of the issue completely done, and a ticket generated where the typical L1, L2 engineer tasks are completed. And what you are accomplishing, let me not go through the individual steps here, but essentially you are looking to deliver proactive live L1, L2 support from the managed services NOC, and it is automatically doing the troubleshooting using your existing applications, your existing OSS systems, and finally coming up with the diagnosis, and you could also build what is the action plan that is required in terms of resolution, and finally the ticket is, a detailed ticket is raised in order to address that. So let me just okay. Hopefully my automation video works here. Oh, it's not. हाँ? ऑडियो नहीं है. हाँ. Let me see if I can start again. हाँ, वीडियो प्ले करो. Okay, thank you. I have one or two more. So this is showing that 6 operational blocks in the workflow are created in terms of the templates. And what you are seeing is on the right, there are different customer circuits which have been flagged off. And the analysis is being done in terms of different blocks that are there in the workflow that I showed. And you are getting a summary of the various circuits that are there based on the analysis. It is put in a fast track mode. So although it's a 2-minute time elapse, but we can look at individual circuits, what is going on. So let's say second circuit, I'm looking at the T5, this thing, and it is bringing the analysis from the okay, so it does the analysis in an automated manner and captures the results and sends it to the whatever is the follow-up system in terms of ticketing. And thereby you have created a zero-touch, 100% accurate system for troubleshooting, and your reduction in manpower could be very significant at a L1, L2 support level. The time required in terms of manual processes, although lots of scripting, etc., is already existing, still the speed up is of the order of about 25x. And for larger networks, it in fact brings even better speed up in terms of parallel processing and high degree of scalability. So this is one use case. Let me go to the second use case. Here we are looking at enterprise service provisioning automation. Idea is this, that you have your PE router, and on one of the ports, multiple customer circuits are getting provisioned. So there is a CP 1, 2, 3, and each customer site is getting connected over a different logical connection, which is a VLAN. And each VLAN is in turn connected to the customer-specific VPN. So this kind of service stitching requires a three-step process, which is shown here. There is some task to be done at the customer edge device or CPE. There is this logical VLAN setup that has to be done at the switch, which is that intermediate node. And then there is a VPN provisioning at the provider edge router. And of course, there are back-end decision making in terms of whether it's an existing customer or a new customer, because then you will pick up the RDRT values, some policies, etc., for the existing one. Otherwise, you formulate the new policies based on the type of customer that is there. So you have information coming from the order management and automatically define what all things that are required in terms of whether it's a hub and spoke network or mesh network, etc., how you are going to connect the VLANs. Also, there could be, complex policies in terms of how much over provisioning I may be doing, or a given interface, if I need to keep certain, bandwidth upgrade capability, so filling up only 70%, etc. All that logic gets mapped into the automation platform. So the network engineering plus the network process in terms of service activation, all of that, gets translated into a software control which comes on top. एक video है. Okay. Yeah. So again, the three-step process is shown in terms of template T1, T2, T3. And this is from the live execution on one of the networks where you are configuring things. If you look at the T2, which is the switch, first you are capturing which are the existing VLANs that are there. Then you are setting up a new VLAN for the customer network that is there at a given interface that is there. And that VLAN, you can see it is VLAN number 4 that has been configured. Similarly, after that, you are going to configure on the PE router the specific VPN or VRF instance. And in order to provision the VRF, again, all the policies and everything, the back-end engineering decision-making has to go. All the information from the order management has to come in. There may be certain database references for the existing customer sites and the policies. And finally, what you do is, you have, provision the So finally, you have a VPN setup success shown here. If there is some issue somewhere, you may have to roll back certain setups that you have already done. So this is a kind of automation in terms of service delivery that you can get. And I'm just, there are 7, 8 different use cases, but I will cover only 3 here. The last one is, something that we are doing with a large network operator in terms of 5G site enablement rollout. Essentially, what you are doing is new 5G services are being launched, and the numbers of end sites are very large. And that's why you need this kind of automation to, speed up the rollout. At the same time, there are complexities associated with introduction of IPv6, because IPv4 addresses are limited, and at the same time, you have your v4 services are also running on the same router. So that means you are essentially setting up dual stack. You may be having your 4G services already, so there are 4G QoS policy that are there, and you are introducing new 5G QoS, which is far more detailed in terms of different types of services that are getting rolled out. And after that, you are looking to establish the services by which you are connecting to the service gateways. And finally, the VRFs for those services are configured, and everything ends by validating through VRF ping to the service gateway. So this is the entire process that is there in terms of back-end engineering for the 5G site rollout. So let me, luckily this doesn't have the video, so I will just show you the screenshots here. So first is, you are looking at the IPv6 address family, and you may have to go to the RR router and check the address pool and whatever the policies that may be there for your IP address. Then you want to configure the IPv6 address family for the service that you are configuring. Also, there would be a export, import, and RDRT policies that you have to set up along with the VRF instance. Then next, you are looking to set up your 5G QoS policies. So whether the 5G QoS already exists or you need to configure the policy and class maps in the router. After that, you need to check whether those are enabled on the interface on which you are setting up the services. And lastly, you need to ensure that existing policy is removed or updated with the new one. So these steps essentially define how you are going to enable the 5G QoS at the given site. Again, this is entire workflow is automated. Every step you can see there is a pre-execution validation. There may be that may have your authentication through, say, NIAM server or whatever authentication mechanism you may have, your actual setup, and post setup you are doing certain validation. So and you are doing maybe hundreds of sites of that. Again, all these templates are multi-vendor. So first you have to sense whether it's a Cisco or Juniper or XYZ vendor, and then roll out a template in accordance with that. Lastly, then you are enabling the 5G services themselves, and there may be a dual stack implementation that may be there. And after that, you are going to check, validate that whatever you have set up is all up and running in terms of operational status. And lastly, you are doing a VRF ping to the service gateway so that now you know that the service could be enabled. And after that, your service engineer or field engineer goes in to configure the site. So whole idea is you don't want to send your service engineer till the back-end engineering is already done. And whatever issues are there, I skipped some of these, but while configuring, there are different kinds of issues that may be there. So you need to create an error log and generate a report so that somebody can look at whatever fixing those issues. And based on this, then you roll out the services. So let me come to the end here. What do we achieve by network automation? Essentially, what you are looking for is lowering your operational expenses, adding new revenue generating services, because many of the OTT services need software control to trigger and configure the services directly and not through manual process. You need something which is highly responsive. We talked about the proactive troubleshooting use case. You want to enhance user experience while limiting your capex. And finally, the high scalability, which is associated with new gen technologies that are coming in. So all these things are enabled through network automation. I have few more use cases. If somebody is interested, I can discuss them in private later on. But thank you. And if there are any questions, please ask. Pankaj, please.
Thank you so much, sir.
Sure.
Network automation is the buzz today, and I don't know if you are aware that for next 3 days we are going to have a workshop on the network automation itself.
Okay, great, great.
So, as for Indian operators, as you know, the mandatory compliance is through the trusted cell portal. So, I just wanted to check if your company or your product will comply or is complying with the trusted portal, because any operator who's buying, whether it's a software or a hardware stuff, has to buy only post the security certification.
Absolutely, yes. So I did not mention, but Vegan has two product platforms. One which is on the network management and operations platform, which is essentially a unified network management, and among them we also provide customer portal as well as customer service management, SLA management, from the network compliance perspective. And the second platform is what I mentioned here, which is the network automation platform. So from the first platform, which is the unified NMS, one of the modules is the customer portal with the security that you mentioned. Thank you. Anybody else? So thank you very much, and I appreciate INNOG for this opportunity. Thank you.
Thank you so much, sir, for your presentation. And with that, we would now be breaking for a little tea break. I hope to see you all in next 15 minutes. I really request you to reassemble here in next 15 minutes so that we can again start with our next round of sessions. I would also like to highlight our sponsors for this event. We have our diamond sponsor, Tata Communications, our gold sponsor, INNOG6 and AWS, our silver sponsors, Alliance Broadband, SIFI, Spectra, World Phone, Nixie and Equinix. Thank you so much. I once again request all the participants to please take your seats so that we can begin with our next round of sessions. I once again welcome you all to INNOG6 being organized by ISPI. And to continue our sessions, I will now take this opportunity to invite our next speaker, Mr. Arnold Nipper. Can we have a great round of applause, please? He's the Chief Technology Evangelist and co-founder of D6 Management.
And I see the presentation over there. No, this one, yeah, yeah. Okay. So good afternoon from me as well, and thank you, ISPI, for inviting me and having me here. So I will talk about Peering LAN 2.0, how we call it, and basically what it is I tell you a short story about our migration to EVPN. So my agenda is first, what are the IXP challenges, then about the migration details, and finally, at the end, the results. So what are the challenges at an IXP, especially at a large one like D6 Frankfurt? So at D6 Frankfurt, meanwhile, we have more than 1,100 ASNs connected with roughly 1,500 routers. So we have 1,800 active IPv4 and IPv6 peers, and there are more than 30 ingress switches from around the world. Most of them, of course, are in data centers in Frankfurt or around Frankfurt. And as you can see, the traffic varies between 6 terabit in the night and almost 14 terabit in peak days. So And what is actually the challenge at a large IXP? So you have to remember that, I guess I cannot run away from the microphone, unfortunately. So an internet exchange is nothing else than a big peering LAN, a big LAN, where everyone has to find each other via broadcast, via app, or neighbor discovery. That means with 1,600 active peers on such a big peering LAN, you have a lot of broadcast, and also what you see is a lot of unknown unicast and multicast noise. So in technical technology, this is simply abbreviated as BUM traffic. And on the other hand, we have port speeds varying from 1 gigabit to 1.2 terabit meanwhile. So the issues what we see is the normal ARP traffic is not really bad, but what we also have is proxy ARP and neighbor discovery. And what is proxy ARP? Proxy ARP is, and sometimes it was a good solution. Nowadays, it's mostly not used anymore, but proxy ARP is a situation where one router answers an ARP traffic for another one. And if, for example, I say, okay, please give me the traffic which is destined for Theodore, then of course all traffic goes to me, and all the hundreds of terabits which should go to Theodore are sunken in my network then. And therefore, that's good. Yeah, I'm more used to run around because the moving traffics are harder to hit. So, and therefore proxy ARP, you never ever want to have it at an internet exchange. So how did DKIC start? Years ago, it was even a little bit complicated already. We have, no, the pointer doesn't work. On the top, you see the edge routers where the customers are connected to, and then to distribute the traffic, this is a typical spine leaf topology. We have core routers at the bottoms, and the core routers simply distribute the traffic and push it to the edge routers again. But meanwhile, how is our topology look like? We do not only run an internet exchange in Frankfurt, we have 3 other internet exchanges in Germany, and we basically almost run 40 plus internet exchanges all around the world. And what we also offer is transport from most of these sites to all the other sites. That means, for example, we also have an internet exchange in New York. Customers from New York may hook up or have a port in Frankfurt. It means it's meanwhile really complex, and it's not simply one switch anymore. So what was our goals for peering LAN 2.0? We wanted, the most thing we wanted to have is EVPN to get rid of all the broadcast traffic. This was EVPN, and also the ARP and neighbor discovery agent. Beside of that, we also wanted to implement BFD, OSPF key change on RSVP traffic engineering for MPLS. I will concentrate in my presentation on the EVPN and ARP and neighbor discovery. I already mentioned the topology. This is the main, it looks almost like an ISP, but every red dot itself, it's really an internet exchange. Only customers connected to that are exchanging traffic, and not with the others one. But in between, we provide transportation. So how does port security at DKIX look like? At ingress, we apply, or we have broadcast traffic. We also see unknown unicast. We have multicast, and then, of course, we have the regular unicast traffic. This goes across the Internet exchange, and at egress, we have the so-called bump traffic, which we restrict to at most 5 megabits per second, and then we have the unrestricted unicast, which is only limited by the port speed of the customer. So what are the issues? What make life hard? As said, our topology, meanwhile, is not only a single switch or a set of switches, it spans across multiple switches, and what you see, the problems is with long-lasting flows. So in between, these switches don't know anymore where the traffic is really from, because the MAC addresses times out, and what then happens is that all the traffic is flooded to all ports. So what happened now? Obviously, I pressed the wrong button. No. So I already talked about this. This is the long-lasting MACs, and what happens there is that if you remove a customer, then immediately this MAC is unknown by all of the directly attached networks, but it's still known by all other devices connected to it. And it takes time for the whole setup or network to converge until it's known that the MAC does not longer exist. What we also observed is VLAN loops, and how can VLAN loops occur. So this can only occur if a customer connects with more than one port to this switching fabric. So this customer has 2 routers, and these 2 routers are connected to a switch, and then the switch in turn is connected with 2 connections to our switching platform. And when the routers continuously inject bump traffic, the bump traffic via the switch circulates, and then increasing, and easily what I said is the port speeds are ranging from megabits to terabits, and are easily then overwhelming these small ports. So with that, what we, together with Nokia, did is we thought it would be easy if we could have an agent sitting on the port, listening to the traffic, and then answering to the traffic. This is the so-called ARP neighbor discovery agent. So the ARP and neighbor discovery traffic is immediately fetched on the port, does not go into the whole switch fabric, and is answered by the agent. This is the idea, and we've put this idea into RFC 9165. It's a standard, so that not only we, but all others can implement this. So these are the background and the motivation to do that, and how did the migration actually work. So with this complicated setup, what we have, there are different scenarios you can think of how to do the migration. So on the left-hand side, you see the different scenarios. If you have more than one router, you can do it router by router. If you have more locations, as we also have in Frankfurt, you can do it location by location. And what you might not have thought of is you can also do it service by service. And what do I mean by service by service? You think you only do peering. That's, of course, our main business to run the internet exchange, but besides what we call the peering LAN, we also, for example, provide cloud services, we also provide VPN, and we decided, or let's first see what the advantages and disadvantages of the different scenarios are. So if you do it router by router, it's of course, in terms of small step, it's a big plus. You do it simply router by router. There are only a few customers, maybe even 100, but it's overseeable on it. Does it reduce complexity? Definitely not. Because if you have done the migration on one routers, maybe 29 are still left. And you have to always to have in mind, if I do the change on this router, which implication does it have on the 29 routers left? Does it reduce downtime? Also not. Because if you have 30 routers, you will have service downtime 30 times. Next, what you can think of, then let's do it location by location. So the engineers, maybe they are over there, it's overseeable, and in terms of small step, of course, if you have these 30 routers in 5 locations, then you only have 5 maintenance windows. It's not a small step, but definitely it's also not a big step. Does it reduce complexity? It does, because the router in one location, they are also tied together, they are interconnected with each other, and from there they go to the other location. That means the implication from one change you make on the router is less than when you do it router by router. Downtimes, again, if you do it location by location, then the downtime only affects this location. The next is service by service. Is that in small step? Definitely not. And personally, I would even give 2 red thumbs down for service by service. Because what you do in one step, you really migrate the whole service and on the whole platform. Does it reduce complexity in terms of what you have to do when you migrate? It does. Does it reduce complexity and the migration to planning? It definitely also does not. Maybe it's the same, because anyway, you have to think through everything. Does it reduce downtime? Definitely it does, because you only migrate the service. Maybe the service will be down for a minute or so, but then it's done. So my team, the engineering team, they decided to do it service by service. And the main reason for that is because then you really have to think through what does this service provide. You have to look at the configuration of all routers anyway, and if you do careful planning, then the downtime for the customers will be minimal. And what we try to do is to set up a testing network. We, of course, could not simulate the whole network. What we try to simulate is at least our Frankfurt network, which is the largest one, and we also integrated the New York network. Besides that, because of the physical testing laboratory, they set up a whole testing configuration system. And this configuration system, they told me, was really the hardest part they had to do. because we already heard it in the presentation before the coffee break, is automation is king and is key. And what they, of course, wanted to do, if you migrated service by service, to have everything fully automated. And what they had to do is they had to go through every configuration on each router and to see, is this configuration like it should be? We know we are all men and we are all humans. What we do, customers calls in, something is not working, so let me see. I directly log into the router and makes a configuration, and then the configuration sits there and is not there as it should be. So that's what they did, and they started small. They, of course, did not start with the largest site what we have in Frankfurt. We have a small site in the US, which is Richmond, and they started there, and everything went well. And what you see here is the bump traffic in Frankfurt. And this is the gap in between is not the downtime, but they had to, this is the monitor port of our system. They had to disconnect for operational reasons the monitor port, and therefore you do not see the bump traffic in between. But what you definitely see is the bump traffic before, which was up to 17 megabits, and the bump traffic afterwards, which is down to, which is it? 1 megabit, which is huge. So from 15 down to 1 megabit. So on these are, I'm not now showing you the results more in detail. What you see is tables for, or figures for IPv4 and IPv6. And you see the traffic packets per second for bump traffic, for flood and learn for IPv4 and IPv6, and you see the huge decrease by that. That means that what we have expected from the migration to have less bump traffic, that definitely worked out. So there are more figures about that, percentages and so on and so on. And I will not go through that, but no migration without bugs and accidents. So what we found out that the traffic distribution with LDP entropy labels was not working as expected. So they have to look in detail to it, and unfortunately also the IPv6 neighbor discovery agent replied with wrong source IP address. Therefore, they had to turn off this feature again and had to wait for a software upgrade from the vendor. Besides that, they were really by themselves astonished that pushing the new configuration to the routers, even for the largest site in Frankfurt, took only 10 seconds, and no customers noticed any interruption. So I guess this is really, so I would call it like changing a wheel while you are driving 200 kilometers. In Germany, you can drive it on our highways. This was well done engineering. That's the end of my presentations. I'm happy to take questions. I was an engineer for 20 years, I guess. I'm not longer an engineer now for 5 to 6 years, so I'm not that deep in any technical things like, for example, Anurag is. The second is, I'm also hearing impaired. I'm wearing hearing devices, but I already found out when questions there was from the attendees that I hardly don't understand this. Happy to answer them, but please bear with me if I say please repeat, or have to pay to someone else to repeat your question. Thank you.
Yeah, this is Ajay Bhardas from Spectra. So what is your plan for this bump traffic in India DECX? So we are already seeing this traffic.
Excuse me?
So
The plans for India.
yeah.
So I'm here with my colleague Sudhir, and Ajay is also here. I happily would like to, how we call it, redirect your questions to Sudhir. Sudhir, if you may come on the stage and answer this question.
Yeah, sorry, if you could just repeat your question. You were saying India-bound traffic, or what are
bump
plans for India?
Yeah, bump traffic, which is already there in DECX exchange. We are seeing this.
Which is already there in DECX, Frankfurt and Global.
Yeah.
Yeah. So currently, as the business case needs to allow any expansion of services, because if you know, we have multiple services across a single access port globally. We would be more than happy to do the same out here in India and facilitate traffic across the globe from India. But technically possible. From a business case angle, it still needs to be looked into, and whenever it happens, like say for example today we've launched Maps as a service, which is a single access port giving you access to services of Microsoft, or Direct Cloud, for example. We make enough and more noise in the market for people like you and the enterprises also to understand that this is what is going to come. We will in due course of time have a solution which helps us touch base with our global exchanges from India. And at that point of time, we will make right kind of announcements due course of time so that people can plan accordingly in their traffic engineering.
Okay, nice, thank you.
Thank you very much.
Yeah, just one query from my side as well. Hello. So first of all, great presentation and extremely, good learning for me in the last 15, 20 minutes. My query was with regards to the migration scenario. It appeared that the most preferred methodology was service by service. Now, my understanding, my limited understanding says that generally what is followed on the peering side is router by router. But here, when you say service by service, can you explain it in more detail by giving example? And do you create separate VPLS when you say service by service? So if you can share some light on that.
Yes, so what does it mean, service by service? So one service, for example, what we offer is the typical peering LAN, which you know in Frankfurt. And for a peering LAN, each customer has a certain configuration. To move from the existing configuration to the EVPN configuration, there had to be made changes on the router, on each router where the customers are connected to. So, and if you do it router by router, then you roll out this configuration to a single router only. You see? And then you run through all the, let's say, 30 routers, which carry the services, and then you are done. But by service, I mean you upload the configuration for the new, not for the new service, but for the EVPN to all routers, and then say, please restart, use the new configuration, and then every router uses a new configuration. So peering is one of the services. For example, connection to cloud service providers is another service. So you do the same on all the routers at the same time, and not router by router by router where you make the change. So does that clarify?
Yeah, to a bit. Do you have a orchestration also through which you manage this service by service?
Yeah, of course, there is sitting an orchestration systems behind it where we check the configuration and then we upload the configuration and restart the services.
Okay. Thank you so much.
Thank you. Thanks again for having me here, and I wish you great success for the rest of the conference and the workshop.
Thank Thank you so much, sir, for your brilliant presentation. Moving forward on to our next session, I would now invite on stage Mr. Saurabh Mittal, Head Products and Solutions Network R&D in Bharti Airtel, and he would be delivering a presentation on the 5G network slicing. Can we have a great round of applause, please?
Good afternoon, everyone, and thank you, INNOG and the ISPI for giving me this opportunity. I think I'd like to switch gears a little bit over here, right? We have heard very technical and insightful presentations in the first half today, right? Let me give you a little bit more perspective on the overall business on the 5G. I mean, India is in the middle of world's largest 5G rollout. And then I mean, you probably would have heard this or seen this kind of a slide, right? I mean, what 5G does in terms of the mobile technology, right? But I think I'll give a little bit additional spin to this. 5G has always been talked about that when we actually move the generations from 1G, 2G, 3G, 4G, 5G, is a industry 4.0 based technology, right? This is something which is going to enable the industry 4.0. But I think there is one more thing which sometimes gets missed out. That is essentially doing a true convergence between fixed and mobile in some sense or the other. So because we have heard so much, and I thought that it might be useful to look at from that perspective as well, that how does 5G today will enable this kind of a true converged kind of a network, which essentially also delivers the broadband to the homes, and also serves the need of the industry, right? So that's all, I think that's one more additional piece which comes into picture. But in 5G, what really has been different, right? I mean, from the previous generation of technologies, if you look at, first, of course, is the peak data rates. I mean, that's something which is very obvious that we've often talked about 10x to 20x, 30x kind of jumps from 4G. Then there is mobility. I mean, maybe the previous speaker talked about 200 kilometers per hour. That's a need in Europe, but I mean, this may not be a real issue from an Indian context, but yes, this is important in some segments. Then what happens on the cell data range, right? So this is something which was in 4G was a little bit more limited scenario. There is a great improvement happening on the downlink speeds. Then the connection density. This is something which we often call the MMTC kind of communication. The next piece is latency. This is very, very significant. For many applications, we have often talked about that, how the control loop, I mean, Professor Hujusaran talked about this in the morning, the control loop delay has to be minimum, so the latency becomes very important there. And last but not the least, of course, how much capacity can be served, right, which is area throughput in some sense or the other, which actually is a significant jump up from the previous generation of technology. So ultimately what it does is it creates new user experience. And how do we actually consume is, I mean, it creates those different industrial use cases. Wherein, I mean, factory of the future, I mean, we've often talked about from a transportation related perspective. Again, I'm going back to the discussion from Professor Hujusaran in the morning. We have been investigating, I mean, some ideas with IIT Delhi within Bharati School of Telecom Management. I mean, how can 5G or advanced 5G, 6G can be used to improve the safety in the transportation, right? I mean, there's not just the logistics part, but also from a user safety perspective, how can this be really used from that part, right? I mean, in fact, I don't know, I mean, you know this or not, but there is a multidisciplinary school within Bharati's, I mean, IIT Delhi, which actually looks at the transportation safety perspective. And they were very, I don't know how to call this interesting, but very insightful statistics which were shared, right? That how the, I mean, pedestrian fatality rate in India has essentially been moving up instead of coming down So we've been looking at how the advanced communications can be used to improve the safety, of the pedestrian and such kind of users. Healthcare related points, I think they have always been talked about: energy, logistics, smart cities, all essentially 5G is going to expand into the multiple industry verticals. And there have been numbers, some reports talked about 12 trillion additional GDP value being created with 5G by 2035 globally, right? 48 billion by next year. Now, if you look at from various use cases, right? So there are different, I talked about, there are different additional capabilities which have come from 5G. And if you try and map these to different use cases, the requirements could be seen from latency, availability, reliability, traffic density, all those kind of different parameters. And there are going to be different requirements or ask for these kind of different use cases or industry verticals, if I may call them. Now, if you map them, and this is the famous ITU triangle on the IMT advanced services, which is another name, and the 5G that we essentially call about, that there are three aspects, right? Enhanced mobile broadband, mobile massive machine type communications, or the affordable, ultra reliable and low latency applications, right? So these are the three vertex of the triangle, and then within that, there are different kind of use case have been mapped. And on the right hand side, these things have been given in different order of, by the different colors, right? Darker green indicating that yes, this could be a major scenario for this. So 5G can serve these different needs, but do we create different networks for each of these industry verticals? I think the key part is that's I'm trying to address in this presentation is that we don't need to create different networks for doing all these things. 5G has different capability. There's just one use case mapped on a radar graph, right? And looking at these different network capabilities: latency, security, efficiency, mobility, massive connectivity, reachability, guaranteed QoS, and throughput, right? These are the different parameters which essentially would be required by different kind of use cases. And then we try to map them to network, what each of these use cases essentially look at. But then the key again point is that while 5G can deliver these use cases for different scenarios, do we really create different networks for that? And the clear answer is that, as a network operators, we really don't want to do that. We really want to create a single network, but virtually partition them and create multiple logical networks, which are independent networks for over a common physical infrastructure. I think that's the concept of network slicing, which is being talked about. And this is, the reason is that it has to be efficient and cost effective, right? This, I think the analogy from the transport world are many. You don't want to build different roads, different highways for different type of users, right? For an ambulance, for example, you are not going to build a different road. For a police law enforcement agency, we are not going to build a different highway. Or for a truckers versus common, person, right? We are not looking to build, different highways or platforms. Of course, there is a dedicated freight corridor in railways, right? Probably their volume justifies that part, right? But it is possible to create adequate mechanisms to give what is required by that particular use case or by that particular industry vertical over that common infrastructure, right? So network slicing is that concept which actually is going to make that happen. So this is like one network for multiple industries. And then of course the logical network has to be managed by the provider. And then the key part is that these are independent and isolated. Maybe sharing the same resource, but they have to be independent and isolated so that we overcome the issues of security, we overcome the issues of, you need the resources, but the resources are not there. And of course, last but not the least, right, the customer or the user can become a participant in the management control or in terms of what we call as the network exposure functions, right? How the network resources are going to get consumed, right? We are expecting that the user of that particular network will be a joint participant in that part. So there could be a possible exposure of the APIs and controls to the customers. Now, another key component which has been happening in 5G is the mobile edge computing. The mobile edge computing essentially refers to the concept by saying that the core nodes in the network, which essentially do the control plane, user plane, or the compute resources, they can be placed in the network, different parts of the network, depending upon the use case scenario, right? They can be more centralized if it is, let's say, signaling heavy kind of resources, or, I mean, the delays can be tolerated. Or it can be, I mean, really pushed out to the last mile network, very close to the customer, if the latency is a very key requirement, right? So depending upon the latency requirement and the traffic requirement, the delay requirements, the edge compute can be placed near to the customer or in a more centralized network scenario, right? So that's something, I mean, the MEC has been a very, very integral part within how the 5G networks are going to get constructed, right? So this is something which is very important from a network slicing perspective. Then the piece comes is, the GSMA essentially has published papers on network slicing. I mean, these are the industries which GSMA saw a lot of potential, right? I mean, in terms of, there could be government networks, right? So for example, the first responder network in US, I mean, there has been work item to say that it could be a shared network, right? I mean, similarly, in India, right, rather than creating one dedicated network, which has a huge cost, the second, allocating spectrum only to certain set of law enforcement agencies, right? Instead of that, there could be more a network slice, if I may say so, right? Given to, for example, the government agencies, all the law enforcement agencies. They could be, for example, a big, I mean, consumer of such kind of a network slice. Automotive, we have seen, right? I mean, whether it is V2X or other kind of applications which can come up, utilities, logistics, entertainment, industrial internet. These are all some of the, I mean, scenarios which essentially are seen as very high potential for the network slicing use cases. But I talked about the mobile edge compute. So how does essentially this correlate to, for example, a private 5G network? Today, a lot of discussion, talks, work items have been going on creating private 5G network, right? So if you look at the left-hand side scenario, it is basically creating, I mean, all these components, complete network in a isolated manner, right? I mean, there is a private network 1, the other enterprise private network 2, and then there is a third scenario which is essentially, it's a public 5G network, right? So these are like, what is shown is 3 independent networks. But if you look at the right-hand side, the way the computes, which is the UPF and the MEC, is distributed, they essentially could be connected to a single network itself. If, for example, and maybe I can talk about it. For example, we've been working with Bosch, we've been working with, I mean, Mahindra's. So if for their industrial automation, they need all the data to be there in that premise, right? Because for the control signaling, they really can't afford any delays. Then we're saying that this could be first use case where the UPF is, I mean, is a gateway through which the connection to the internet or the outside world or the application go out. This can really be, I mean, put into the enterprise, I mean, premises. And rest of the network essentially could be within the operator network or in a more centralized environment. If there is a, I mean, enterprise network 2, they probably don't need these kind of pieces, but they need more of a capacity related part, right, which is essentially to be given by G node B. Then we can have a second scenario. There are obviously the third and the public network essentially can also be supported on the same set of network, right? So essentially instead of creating a dedicated network for the enterprises, we can have a shared network for the enterprises, and depending upon the usage scenarios, that network slice partition can be done. Now, the big ticket item is, how to do it? Because there are these kind of different resources which is spread across the RAN, then the transport, the edge service transport, and obviously the core network and services which essentially come into picture. The biggest piece is obviously the RAN resources, right? If you have a BTS or a G node B, as we call in 5G, serving different types of consumers, consumer classes, or the network slices, then we really need to partition these resources. Resource 1, 2, 3, 4. But then these resources have to essentially get stitched through the network, which is whether it is a transport network, or the edge services, or the computes, or the VNF in the core network, right? So they all have to be stitched through these entire components, right? So that's a big ticket item, big work item. I was speaking to Professor Girish in the break, right, that the automation becomes absolutely critical for such kind of a network deployment, right? And this is not just multi-vendor interworking that we are talking about. We are now also looking at orchestrating these resources across all these different domains, right, which traditionally have worked through different kind of standards over a period of time, right? I think that's where all these complexities start to creep in, right? But that's something which will be, in a minute, we'll be looking at, right? And that's why we see a significant effort within the standard bodies, the SDOs, to do this end-to-end network slicing. So if you look at on the RAN network management, the 3GPP, OpenAI, ORAN have been working together. The SA, the system architecture group, SA2 is something, and SA5 have been leading this work item. Then when it comes to the transport management domain, then IETF, MEF essentially have been working a lot, liaising with the 3GPP to make that happen. Similarly, on the O&M management, we see TM Forum and the 3GPP, working out. So if you look at network slicing is one work item where if I take the convergence to the next level, is also the convergence in terms of the standardization and how do we actually collaborate to deliver the value to the customer at the end of the day, right? So, and there are like industry alliances like GSMA, and the NGMN, which have worked on the user requirement to the standardization body, working together and delivering making this really happen, right? Because what basically I'm describing is still, I would say, a work in progress, right? It's not easy to make this network slice very seamless across the network today, right? This will probably happen with 5G advanced, but this is something which is really important in time to come. Just very important piece, right? That how do you actually, create a slice, right? So on the slices are essentially defined by the end user points, right? Because, it is thought through that the UE, which is the mobile in case of a mobile operator, but there will be different types of UEs which will come into picture in different form factors. These could be variables, these will be machines doing machine-to-machine communication. So they are the ones who will be really asking for the slice. So there is a new indicator called as NSSI, which actually has come up in the standards. This is something which will be used to define the slice across the domains, right? So the way, for example, we had the QS, DHCP marking, right? I think the standard bodies essentially are now, and different people called by different name, right? Whether you call that DIFServ or DHCP or, the QS, QCI marking in the mobile space. Now there is going to be a network slice indicator, which is going to come into picture, which essentially will be used by the different domains to say that, okay, the resources belong to which part of which network slice, right? So that this can be really orchestrated through the network, right, on an end-to-end basis. I'll not go into the detail on this particular part. I have done, what I have done is that I have put through a bunch of references which are, I would say, most relevant, right? In case you want to go through more details, you can refer to. Of course, you can always reach out to me as well, right? I mean, in private, we can have certain discussions. So these are across GSMA, 3GPP, MEF, I mean, Broadband Forum, TM Forum, which, I mean, many of the standardization bodies which have been really working on the network slicing. So I'll actually not stand too much between you and the lunch. I believe that the network slicing is one thing which is going to truly unlock the full potential of 5G or 5G advanced and 6G in times to come. Thank you, and happy to take any questions. Okay? Yeah, thanks once again.
Thank you so much, sir, for your insightful session. Moving forward to our last session before the lunch break, I would now be inviting on stage Mr. Deepak Rathi from Reliance Jio, and I request him to please come on stage. Can we have a great round of applause, please?
Number 8. This one. This one. No, no. Yes, Arjun. Yes. View. Full screen. Full screen mode. Okay. Thank you. So I am Deepak Rathi. I am from Reliance Platform. So I look after sales and development of 5G in enterprise and CSP markets, domestic as well as globally. So as we know that Jio has already launched 5G services last October. We have already reached around 300 cities, and we plan to reach all the nooks and corners by end of 2023. My topic today here is 5G use cases. My earlier friends, colleagues, they have already covered 5G and some part of use cases as well. So when we talk about use cases, we have to understand one thing, that the typical features of 5G is ultra low latency, high bandwidth, a high capacity. So depending upon the different industry requirement, different use cases can be created. So one of the area where 5G finds prominence is in healthcare. So these are some of the use cases in healthcare industry, like in the ambulance, then tele-ICU, drones, telemedicine, radiology, UV disinfection, for hospital intralogistics, and 5G-enabled medical VR solutions. So we'll go into detail one by one. So this is the connected ambulance. Here we see that whenever any accident happens, the initial 1 hour, we call it golden hour. That is very important. And if proper treatment is given to the patient, there are good chances of their survival. So it's a very simple setup. Here we see an ambulance. All the equipments, they are connected through a modem to a 5G network. So all the body vital parameters, they are being fed to a doctor who is sitting remotely. Video feed is also available. The doctor sitting remotely can guide the paramedic staff to what needs to be done till the time the patient reaches the hospital. So the main ambition is that during the transition time from the accident site to the hospital, the patient can be kept healthy or alive at least. So this is one of the critical use case we find in 5G. This is another one. So we know that still 67%, more than 65% people, they are in the rural area of India, and they do not have access to critical health care. So here again, the doctor who is sitting remotely, he can guide ICU, which is in the remote location, in the rural location, what exactly needs to be done, because the critical health care, it has still not reached to those locations. And all the body parameters, all the vital parameters, they are being fed through some common application platform. All the reports, they can be sent over there. So when we talk about 5G, we have to understand that we as operator, we are there to give them the platform for the connectivity. Rest use cases, they have to come from the industry itself. So this is the tele ICU. This is the drone, usage of drone in medical healthcare industry. Anything which needs to be transported, places like, maybe due to challenging weather condition, hilly area, maybe due to storms or due to unfavorable weather conditions, whether it's a medicine or it's a blood bank, whatever needs to be transported from one place to another place, it can be done using drones. So we have seen that nowadays drones are used for the food delivery as well. So that is another use case where latency will have different requirement. In this case, latency will have different kind of requirement. This is telemedicine. We have been using online consultation of late. During Corona time, we realized that the in-person meeting, that would be less desired. So here, online consultation can be conducted for off-site location, for a rural location, to the mainstream where the doctor is sitting. And again, all these equipments are connected via a modem, and they're, all the data is being fed through an application platform to a doctor who is sitting remotely. This is radiology. Again, all the radiology tests, they can be done remotely using a haptic device by a radiologist who is sitting remotely. And all the heavy files, these X-rays, they are very heavy files. They can be sent in real time to the remote location. So that is another use case we find in 5G. This is again, these are the robots, or tug robots which are moving, and they can help in disinfecting any area, like in the hospitals. A typical room is typically 25 square meters, and it takes less than 10 minutes to disinfect any medical room. Again, there may be several logistic requirements within hospital to transfer the food, to transfer the medical equipments. These tug robots, they can roam around within the premises, and they can transport the required material. So another requirement which we feel, where 5G finds good traction is in the manufacturing segment. So basically there are two areas. One is the warehouse management, and another one is in the manufacturing area. So in warehouse segment, we see that these tug robots, they can transfer the material raw or maybe the prepared one within the premises. So all the warehouse management, it is done through it. In India, we have two commercial deliveries. One is in our own in-house Reliance Industries, another one is Sanmina, where we are, the end-to-end warehouse management is done by robots. So these are the photographs from there. And of course, if it's a robot or the robot with arm, we call it cobot. That can be used for any production line, we can see, for it may be sorting of material for any packaging activities. 5G is also used in industrial training using AR, VR, XR, mixed reality. So all these different kind of applications, they can be used for training for any 5G uses in any industries. Public safety, we can see that a lifeguard, it is being sent to a swimming pool or maybe to the sea area. So we can use these drones for the aerial surveys during any natural disaster. Connectivity is one of the key requirement, and 5G can be used over there. Another area where we find 5G usage is in the field of entertainment. You can see all the cloud gaming, streamings. We have Geo apps, immersive 360-degree, where 5G is used. Since the requirement of bandwidth is very huge in running such application, so 5G is very much capable of running all these applications. This is for the metaverse. You may have seen that if you wear these glasses, then you can feel like that you get a 360-degree view of any room. For example, in any meeting, you can feel like everybody is sitting around us. In Teams also, there is one of the feature where you can make people feel like they're sitting in a classroom. So with these glasses, you can actually have 360-degree round view, and it finds usage in learning activities or maybe in the in any virtual events. For example, if we attend this event from the home wearing this glass, we can feel like we are sitting in an auditorium. We can see all people around us. So these are the typical 5G use cases. What we say that many of these use cases, they need to come from the industry. Again, we as operator, we are here to give them the platform, to give the 5G leverage, the features of 5G. More and more requirement comes, more and more use cases can be developed. Jio has developed 25 use cases across industries, and in fact, we have one experience center based out of our corporate as well. We had showcased some of the use cases in Indian Mobile Congress last year in October. I'm not sure whether some of you had the opportunity to come at our stall. So this is what 5G use cases are, and there can be many more, frankly. There can be many more. My presentation ends here. If there is any question, I'll be happy to answer.
So I have a question that
I can hear. I know your voice, mic is not working. Tell me.
so I have a question regarding what is the application feedback mechanism to the network slicing that is there. In the sense that, let's say you mentioned the streaming requirements, etc. Suddenly there is some activity going on and I need to stream. That means I need to configure higher bandwidth through this thing. But that has to be driven by the application, or you talked about that large files, etc. When that need comes, at that point I need to configure higher resources for this thing. So what is that feedback mechanism from application or use case into the network orchestration that typically is envisaged?
See, when we say network slicing, I would say it's a very complex, and see, when we say slicing, doesn't mean that something is sliced into. These are the same physical network, which is logically separated. A typical handset mobile, it can last to 8 different kind of quality of services. When you get into the 5G, the quality of services is the concept. All applications, they are already tagged to one type of quality of service. Your mobile handset, it is capable of latching to 8 different type of quality of services. For example, when you are using drone, that require, or connected cars. These are the things, for example, radiology, remote surgery. These are where the latency requirement is very low. You need to have things done in fraction of seconds. There would already be a slice. Whenever these applications run, they will run only on those slices. You don't have to latch it. When you open this application, it will be latched to that slice itself. Same is the case, for example, let me take it for any IoT application. Let me take it this way. IoT application, frankly, IoT does not require 5G, though we do push that with this 5G, because the capacity has increased. Millions of devices can be connected per square kilometer. But IoT does not require 5G, if you look at the bandwidth. So there would be a separate slice. So when you open one IoT application, that would already be latched, that would be decided that it will go through that slice, which has less bandwidth requirement, less data requirement. So it is like this. All the, for example, video requirement, it's a guaranteed bitrate. When you're using voice, that has the highest quality of service requirement. Guaranteed bitrate with GBR, we call it. It's already decided. Whatever you're doing, if you're making a voice call, everything else will stop. So like this way, depending upon different requirements, different quality of services, they are already designated for those applications, and it will run only through them. No, resources are always there. All the core networks, see, slices, when we say slice is function of RAN, core, and transport. So RAN, there is a access call barring feature, it can still be implemented. When we talk about core, there are so many network functions. There are 27, 28 network functions. When you get into it, you don't require all those functions. Let me put a simple example. When there is a private network, for example, if any of this has private network, it's a dedicated slice for you. You don't require network selection function over there. For any enterprises, if you have not opted for voice, there would be, core is nothing but amalgamation of so many microservices. So depending upon your requirement, what solution you have chosen, those applications would be decided. So if there are say 750 or 800 applicants, I'm talking about the microservices, you require only say 250 applications to run that particular service. So only 250 will be used over there. Rest will be removed. So when we talk about slicing doesn't become like, for example, we have discussed our Mac services as well. User plane consumes most of the data in any, there is a user plane and control plane. So if my user plane is near to me, it's near the edge. So for 1 Gbps, that is the minimum bandwidth required to run any 5G services. So if I have my UPF place over here, for control plane, I don't require more than 100, 150 Mbps of speed. More than that, it is not required. This is what I'm saying. Different applications, different use cases, different setups. If you have EMF, SMF, UPF installed within the premises itself, you don't require high bandwidth going outside. Maybe I would say 100 Mbps, maybe 80 to 100 Mbps would suffice. This is how it runs. So depending upon different use cases, what exactly you are looking for, you will have different kind of setup, different kind of connectivity. And these all are microservices enabled because when we transition to 5G, this 3GPP, they disintegrated complete core. And this is the reason where we say that we were able to draw the efficiency of high speed, bandwidth, ultra low latency. This is how it has come. Otherwise, in previous monolithic structure, everything was stacked together, lock and stack at a remote location. So in Geo, like we have 8 super core locations. Previously, we were covering just two core locations across India. I'm talking about LTE and 4G. So this is how, I think maybe I spelled your query too much, but I've been able to answer your query, I guess. And you have a question? Yes, please.
Just a follow-up query to what sir asked earlier. So, I mean, and it's not only for you, it's also for Mr. Saurabh, who presented on the same concept in the earlier session. So, I mean, when you say network splicing, whatever use case you talk about is not a function of just the speed, because like you said, IoT doesn't require high bandwidth, but it is critical, right? There's, especially in the manufacturing, healthcare, smart cities, women's safety, everywhere you see IoT concepts coming in. So when you say network splicing, what is more critical from a network point of view? When there is a live streaming of a match, like on Geo Cinema, there is a live streaming right now of the Premier League, IPL is coming up, or industrial IoT will require, is more critical, or like in US we have the first responders network. So which kind of a use case scenario will get a higher priority on the network? Is it only on the basis of bandwidth consumption? Because some application might require high latency, but might not require the radio resources all the time. Like in case of IoT, it consumes the battery of the end device as well. So it varies from application to application. So how do you treat these three scenarios on the network side from a priority point of view?
See, I would say it's not the selection that, if 3 services are running, then I will stop 2. Doesn't happen that way. Yeah. All 3 services would run, but the requirement is different. My capacity is 2 Mbps. Some other application capacity might be ultra low latency. Some third might be 100 Mbps. They all can run simultaneously. So there is no discrimination based on this. The only thing is that based upon the requirement, different paths are giving. I'm talking, not in the logical sense, but just in the layman. Depending upon your requirement, you're being given a specific path. Let me put it this way. All 3 are important. I'm saying if you're making a voice call, it's a guaranteed bit rate. So you can have an interruption in your video. In a video, you can have interruption. You're playing YouTube anyhow. If you're taking a voice call, that stops by itself. So voice is utmost. That is the first requirement. But again, I'm saying, when you move to 5G and these network splicing, we're not talking about 4G network splicing and all. When you're talking about all applications can run simultaneously. Don't think that one is running, then it is overcoming something other. So it doesn't happen that way.
No, I understood, but I was just talking in terms of prioritization.
There's nothing defined as such. For example, if you're a private setup, if you come to me and say that, okay, I want this kind of network, where for example, in case of manufacturing, the machine, they all have sensors and, different UEs. Their requirement is ultra low latency. So there will be a dedicated splice, which is given over there. For them, voice is not the requirement. For them, running the plant is a requirement. So it will have more priority compared to voice applications. For people like us, voice has more requirements. So this is what I'm saying, depending upon different setup, different requirements, different private, these all are private 5G cases. So depending upon the use cases, different prioritization is given. But again, I am saying, prioritization doesn't mean something is kept on hold. It simply means they're prioritized based upon the business needs.
Thank you. Thank you.
So,
Last
when you
question,
say
please.
network slicing, okay,
Yes, sir.
so does it mean that we have got the dedicated slices?
Sir,
With respect to some particular applications. Now,
see, my topic still remains restricted to use cases, and slicing is something parallel which my friend has already covered.
So I tend to say is, let's say I'm having 10 applications at a time, and I've got a dedicated slicing for this. Okay. Now, for a particular point of time, let's say my application number 8 and 9, that requires more bandwidth. So is it possible to induce some sort of SDN controller in the network, which may reslice the network as per the application requirement? I guess that is some sort of SDN and NFB. Just correct me if I'm wrong.
Yeah, please. Please, come over here, sir.
Check.
Thank you. I think just so that, sorry for.
No problem.
First is network slicing is more than QS, right? I think first and foremost, I just wanted to clarify that part. So it's not just the traffic prioritization or the QS when we talk about the network slicing. This first part. The second is the actual implementation of network slicing is still, I would say, some time away. It's not that the networks have implemented, because it's fairly complex to implement on a end-to-end basis. But in the network slice, what you said exactly is important, that you need to have an SDN controller, you need to actually have a NFV controller, and everything is supposed to be coordinated by something called as the network slice controller, right? And the network slice controller, as I had mentioned in my slide, will have certain exposure to the end customer also, depending upon the agreement with the customer, right? For example, Professor Girish asked, right, if there is an on-demand ask. Now, on-demand ask is a characteristics of the service level agreement which will be there with the slice provider and the, let's say, the business or the use case, right? So depending upon that SLA, right, if they have the ask of saying that, okay, you can, for example, in the IP world, you do an oversubscription. In this case, you probably would say that, okay, I have an on-demand need, but then on-demand need has to be defined, right? So that the network resources in an overall sense can be really, asked for. And to what, this was talked about, right? The resources will be across RAN, transport, and core. For example, if you need, and the previous question which was there, right? That there is a entertainment service which is running, there is a MMTC service which is running, and then there is a FirstNet service which is running, right? So if at all there was a conflict, because I'm believing that there will not be a conflict, but if at all there is a conflict, what can happen is that, for example, the bandwidth of the slice of the entertainment could come down, right? You still may say that, okay, instead of very high HD quality, I may, for example, come down. So these are the things which could be part of the SLAs which are there. So it is something beyond the, first of all, the QS related part when we talk about the network slicing. It is something which will get implemented, but depending upon the service level agreements, people will, and the network operators will configure the network resources more thoughtfully, and then, as a result, and we will be requiring to use an SDN controller, an FV controller, and an overall network slice controller to make these things happen in real time, dynamically, and depending upon SLAs, on demand as well. Yeah. Thank you.
Thank you so much, sir, for your presentation. And to everybody seated here, you can bring up your questions and queries during the lunch hour. And with that, I would now be inviting on stage Mr. Rajesh Charya, President of ISPI, to kindly felicitate all our speakers with a Mithila Lok Chitra Kala, a Madhubani painting, as a token of appreciation and efforts. Can we have on stage with us Mr. Deepak Rathi? Can we have a great round of applause, please? I next invite on stage our speaker, Mr. Vivek Nigam. Do we have Mr. Nigam with us? I would now invite Professor Huzur Saran, Dr. Girish Saraf. Can we have a great round of applause, please? And now, I now invite on stage our speaker, Mr. Arnold Nipper. Can we have a great round of applause, please? I now invite on stage Mr. Saurabh Mittal. Can we have a great round of applause, please? We are grateful for the time and the effort you took to show your stimulating presentations to all of us. And with that, I now request all of you to join for the lunch break. We will reassemble again at 2:30 p.m. for our next round of sessions.
The lunch is served in the lecture hall complex. It's just opposite side. So we can all go there together. Thank you. It's on the ground floor, lecture hall complex, just across the road.
And once again, I'd like to highlight and thank our sponsors for this event, our diamond sponsor, Tata Communication, gold sponsor, APNIC and AWS, silver sponsors, Alliance Broadband, SIFI, Spectra, Worldphone, Nixie and Equinix. I hope to see you all once again sitting here at 2:30 p.m. Thank you so much. I once again welcome you all to INNOG6 being organized by ISPAI. Moving forward to our next leg of sessions, we have with us Mr. Tony Leong. Can we have a great round of applause? He will be joining us virtually. He is the Business Development Director at Equinnis and is responsible for the new market and interconnection strategies. He's also the regional development for APAC.
Okay, thank you. Let me share my slide. Are you able to see my slide?
Yes, we can see your slides, sir.
Okay, I shall begin.
Yes, sir.
Okay, well, thanks for inviting me to INNOG. My topic today is alternative peering method. I'll jump straight into it. I think we all know what peering is, but maybe I'll just give a quick sort of intro on in case someone doesn't have a detailed knowledge on peering. So peering as we know it, we have the private peering, which is basically an interconnection between two networks using a fiber, connecting two routers from two different networks, establishing a BGP session and exchanging routes, and therefore traffic goes to each other network. And that's the private peering. And we have the also public peering, which a lot of you might be very familiar with, as there are many internet exchange in India. And that's simply a router connecting to an internet exchange and establish multiple sessions with various peers over that internet exchange. And a typical internet exchange would also have a route server where you can connect to and announce the routes that you want to announce. And I think in some cases there are policy on what routes you should be announcing on route servers. But essentially you can, if you're connected to the route server, you can receive the routes that are sitting on the route servers. And you don't have to be establishing individual sessions with every single networks that are connected to their internet exchange. Now, just a quick comparison between private peering and public peering. Private peering, obviously, you have a guaranteed peering capacity because it's a dedicated fiber between two networks. Very cost-effective for high traffic volume peers. It's easier for you to monitor your traffic because you are seeing everything between you and your peers. Arguably quite secure and reliable because the fiber cross connects are within the data center, usually through a meet room which nobody can go in other than the data center provider. And for the public peering, it's obviously very efficient because you are peering with multiple network with just one connection and one port or multiple ports in some cases. And it's very cost effective if you're peering across multiple data center within the metro. And it's very easy to activate, especially if you're connected to the route server. You probably don't even need to do too much with establishing any more bilateral peering. And like I mentioned, route servers are typically one of the features that are on the existing internet exchange So what is the alternate peering method that I'm going to talk about? And I think I'm using a general term here, switching fabric. I think a lot of you are very familiar with kind of a fabric or cloud exchange terms or whatever connect that various different providers are using. And the two key components of a typical fabric, what I use, it's a port, obviously, similar to the internet exchange, where you connect your router to. A connection, which is a virtual connection that you create on the fabric itself. And the typical use cases that you might be using it already today, it's to connect to cloud or software service provider, or using it as a disaster recovery or risk mitigation or redundancy purposes, or connecting to multiple locations for distributed hardware. That's the typical use cases. So what is it that we want to do with peering? Why is it good maybe to use this method for peering? So let's have a look. So the first scenario here I'm talking about, it's automation. Now, if you look at the diagram on the right-hand side, I'm explaining, I'm showing the traditional PNI where you use a cross connect, where on the left-hand side, you're using a switching fabric and you are creating a virtual PNI, which is basically a VC using switching fabric on the VC to connect to each other. And you can easily establish that because it's fast, and the automations are usually enabled, or API, enabled on the switching fabric. And so you could easily write some script to establish a connection quickly. And a lot of the providers are also providing various different bandwidth on the virtual connections, so making the commercials a lot more flexible. And you don't have to commit to the whole year. In some cases, a lot of people are offering services on switching fabric on a daily basis. And it support very similar to the internet exchange, where you can have multiple PNI established on that. Now, the main difference between this switching fabric, sort of what I call virtual PNI, when compared to the internet exchange, it's the fact that internet exchange, there's no visibility on your peers' port capacity or congestion level. So whilst you might have 100 gig on your internet exchange, and you might have 80 gig headroom on your port, and you're peering with another network, and they might have multiple 100 gig, but the port may be 90% utilized. And there's no way for you to have that guaranteed capacity. Whereas if you're using this switching fabric, you can create that bandwidth based on your virtual connection, and that therefore it will guarantee you that capacity. And that's the main difference in this case, whereas the internet exchange, it's very hard for you to know what the other peers got. In fact, you won't know. So let's look at another scenario, remote peering. In this case, I'm showing a network with a router in Singapore. And this network wanted to peer with someone in SL is Seoul and P is Perth in Australia. And in this case, a lot of the providers do provide international fabric connections or switching fabric connections over their own backbone. And so you can utilize that. And you can utilize that to create multiple peering connections to locations, like in this case, Perth. And you can also have another connection to another country. And you can aggregate them onto one single port or multiple ports, depending on the capacity. But again, I think the key things here is that not only because you can do remote connection, I mean, you can do that using IPLC anyway, but remember, once you're connected to the fabric, you can establish sessions much quicker than you ordering a physical IPLC between country. And as I mentioned before, flexible terms are the key for a lot of these services now. So you can commit to only, you can only use it for 2 or 3 days, and you can take it down without signing a year contract. And I think with the automation as well, this is very useful to a lot of networks that might have a special occasion or period that they see a particular rise in traffic. So this is an extremely useful case for remote peering if you needed to connect to someone overseas. And the next scenarios, I wanted to kind of go deeper on the remote peering. What I've shown here in Perth is to put a virtual router. And I think virtual router is now becoming very common for a lot of the people, not necessarily network providers, but in some cases enterprise customers too, because they don't want to spend the capex and the resources to build a point of presence in a particular country. So in this case, I'm talking about peering, obviously. You could have a virtual router there and aggregate all the virtual PNIs together, and then all the internal trunk between your virtual router and your router in Singapore. And you can save money because you're aggregating your peering traffic. Depending on your peering traffic, you can order your trunk flexibly. And again, the flexibility of the terms and all that makes this a very useful and attractive solution, especially if CapEx, it's not something that you can easily justify. Or maybe you want to just test the effectiveness of peering in Perth in this case, and you just want to see how viable it is to peer with people, or the performance, and you want to test it prior to fully deploy a physical hardware there. So this is a good use case for people wish to kind of test the peering locations. This can also be applied to transit provider who might want to sell transit in the location, but that's not the topics of today's discussion. And I'm showing another remote peering, and in this case, what I'm showing is a remote peering within a metro. So in this case, I'm showing particularly Mumbai, where a lot of the providers have multiple locations, and because of the regulatory issues for some networks, they can't, even though the provider might have fibers, but you can't order a fiber or use a dark fiber between data center because you don't have an appropriate license to do so, even though the two data center could be just 1 kilometer next to each other. And this fabric service can actually help that and can help you to establish peering much easier than trying to order a fiber and get a license. And of course, you can also do that in the internet exchange, which is very similar to this. But again, the same problem which I explained before, it's this virtual PNI, it's guaranteed bandwidth, and you can switch it to whatever level that you like without worrying about or maybe the other party doesn't have enough capacity, because this is the dedicated connections. And the last two scenarios I wanted to show here is related to subsea cable fault. And I bring this in because this happens to a lot of the networks in this region. And I use Vietnam as an example. As some of you might know, there has been quite frequent subsea cable cut in Vietnam. So in this case, what I'm showing is Pier A has a router, obviously, their home domestic market, and the backbone capacity connecting to Hong Kong and Singapore using various different cable, APG, AAG, TGN, IA, and AE1 in this case, as an example. And they are peering with a network, PB, in Hong Kong and Singapore. They could be carrying over 6 gig of traffic with a 10 gig port on this public exchange. So what happened when a cable is cut, whether it's a single or dual cable cut? The chances are, even if it's just a single cable cut, the network PA in this case don't have the capacity to bring back to Vietnam. And therefore, naturally, especially in the dual cut failure, naturally the traffic will be moved to, say, in Singapore. But the problem is you don't have enough capacity on your public peering, or maybe you have, but your peer doesn't have. And therefore, the best solution would be to establish the virtual PNI here through the fabric, you know, because you can do it very quickly, and because of the flexible term, you can tear it down as soon as the cable is restored, and therefore you have your backbone capacity back in Hong Kong, and you can easily restore the traffic back to Hong Kong, and you don't have any commitment to your circuit, because most provider on the switching fabric offers very flexible terms. And the next scenario, it's very much similar to what I've described, but this is kind of on a private peering case. Again, you could be having a 10 gig peering capacity between the networks in Hong Kong, but you don't necessarily have enough to cater for a failure scenario in Singapore. So again, you can easily establish a virtual PNI between you and your peer, in this case, peer A and peer B in Singapore, and until the capacity has been restored between Hong Kong and Vietnam. So these are the typical scenarios that we could think of, and why we should use the switching fabric. Now, the catch here is obviously, your peers has to be connected to the fabric or the switching fabric or the same switching fabric providers. Otherwise, it makes it very difficult for you to establish a session between two peers that are connecting to two different providers switching fabric. It might work, but it won't be very cost effective, I think. But usually a lot of the data center now offer switching fabrics themselves. So this could be a solution that would help you to plan your peering, to cater for fault scenario, etc. So I hope this brief introduction of fabric for peering was useful and insightful. Thank you. Questions, anyone?
Do we have any questions for this session? With that, I thank you, sir, for your brilliant presentation on the topic. We would now move on to our next session, for which we have with us Mr. Ramesh R. Chandra from Reliance Jio Infocom. Can we have a great round of applause, please?
Thank you.
Thank you very much for the introduction. So this is the second session post lunch, and as usual it becomes difficult to remain connected, right? So I think we need to do something about it, right? Thanks to organizing committee for giving us time to come and talk in front of distinguished leaders and the people who have been contributing significantly for the betterment of the internet. So it's very honor to be in fact with all the people and have a close interaction. Maybe we will spend some time based on whatever time is allotted to us. Beyond this, we can have a discussion even after the session also. I think we need to, there are a lot more technology, we need to talk about it. Okay, a lot of technical stuff is getting embedded to the network, where we talk about cloud computing, 5G, slicing, and even the work has already started for the 6G. Okay. So very soon, we are going to initiate and have a discussion even on the 6G. So today, what we plan to talk, some of the business cases, some of the services, what are required, and the industry need to empower when the customers, how they can avail the services, or how we can improve the network design and architecture and enable these services through the same even IP-based network, what is every operator even the worldwide had today. No, that's okay. That's okay. That's okay. So, some of these challenges what we have seen over the IP-based network while delivering multiple services, we will touch base each one of them little more in detail. Okay. What do we want to talk about? There is a hyper digital growth. What we have seen is not only India, even outside also. Okay, and there are a suite of services which are going to, we will talk about Quad and Quad plus services, okay, little more in detail. How do we overcome? By improvising the network architecture and the way we in fact create the services. We'll also see how we can improve the customer experience, which is very important. At the end of it, no matter what service we offer, what matters most is how the customer is getting delighted, how he is able to fulfill his business needs. And some of these network improvement, we'll talk about it, what is segment routing all about it, and how we can use, how the IPv6 enabled us, okay, to amplify our network, okay, exponentially. So some of these factors, if we try to put them vertically in the three parts, where we say digital trends, and some of these, although there are a long list, but we will talk about few of them, where we say rapid adoption of mobility, right? We have seen the mobility growth, and if we talk about only India numbers, I think in 2012-13, I guess we were close to 890 million subscribers, right? And if we look at, in fact, now data away, I think we are over 1.157 billion. And if we just see in terms of numbers, it looks to be almost double the numbers. But if we look at in terms of volume of the data which is carried today, it's like million times. Okay? It's a huge growth which you have seen in the network. And if we say, what are the other trends like growth in social media? I think this is very common. Many people have multiple accounts, right? One account, okay, which is shared with the family, with the people, and then there is another account young generation have, okay? And you can imagine what not is happening on that, okay? So everybody has multiples of accounts, okay? And be part of the growth story. While we do it in the social media, even at the same time, there's a lot of focus which is coming from the government side. How do we enable every citizen of the country? How we can empower a common man of the country, where we offer and extend all these services to the smallest remote places in the country, and how everybody can join in the growth journey of the internet and the services. Younger generation, I think, if we look at the India, our average age, I guess, which is 27 years, and younger generation. And I think this is one of the lowest younger generation we see it. It varies 26, 27, 28 years. It goes to 65, 75 years, right? So we have a lot of young generations in the country. They have a lot of potential. They have huge potential to explore and use their energy and their impact now knowledge base, okay, to use and for the growth of the services, growth for the internet, growth for impact now even the community. Now we also see that a lot of entertainment growth, and I think the COVID the last 2.5 years have taught a lot of many lessons here. Previously, like even the 7 AM entertainment, we used to visit in the halls. Even now, the trend has changed. It is shifted. It is more of a online entertainment, which is becoming more common. Rapid technology innovations, I think, is very good about it. Although considering even the previous trend, which we see even from the India, not many innovations. But if we see recent trend, I think a lot more innovation. This is a very positive trend and very exciting trend, which we see even now. There is a vision and there is a thought process, not only the government, even the private sector, where like every household should have a internet connection. Right? There is a very tall, in fact, now objective and initiative, but I think there is effort which are going on, how we can in fact take out even the fiber and some sort of in fact now connectivity to every home, so that all the citizens, like services we talk about, all the internet services we talk about, how the information can reach to every home, okay? And this can be like, this is possible only when we reach out to every home in some form of the network and connectivity. Now, while we see traffic growth, I think this is 500 million, what we talk about the 4G, 5G subscriber, the actual number is much higher, okay? These 500 million subscribers, if we look at it now, previously we used to talk about 890 million subscribers in 2013, okay, generating in fact now the data volume, which was very, very, very small. This has changed the paradigm shift in the way we operate, the way we do the business. In 2012-13, the business model was that we provide almost data services free and we charge only for the voice services. That was the model, right? If we see the model today, voice is completely free and only data services people are paying for it. So there is a paradigm shift in the business model, okay? How do we used to operate before and what is the current model which is more common? Connections, I think machine-to-machine communication is just, in fact, now knocking the doors. Okay, the huge tsunami of the transactions is going to come, okay, in the internet, in the IP network, in the MPLS networks. Okay, it is not that volume of the traffic is going to increase, but volume of the transactions which is going to happen with the M2M coming in the picture for various use cases. I think it was talked about in the previous sessions also. Okay, number of transactions going to be huge. And if you look at the current data consumption, I think we have seen even the trend, it has been growing very rapidly. And even today now, what we see, many of the places, many of the states where average data consumption per subscriber, when has reached more than 250 GB every month. Okay. And this is going to further increase. Speed, when we talk about how we deliver, not only the connected speed, is that the speed where we can deliver the content to the subscriber, what we talked about today, 1 Gbps, right? And there are the efforts which are going on, okay, how we can improve further. 1 GB, yes, is very, in fact, now significant, high volume. Not many applications today which need more than 1 GB. But as new services do comes, and then this 1 GB, there is effort how we can increase to 10 Gbps when the connection to the every home. Okay. That is the effort which is currently going on. Okay. And we see the trend, what is the mode traffic which is dominant today? is more of a video contents. That is what is becoming more than 80%, 83% of the content which is being consumed today. These are the video contents. While we see the digital trend and what we see the traffic growth, okay, this brings a lot of impact in the network. For example, okay, largest like now internet with IoT. IoT we just talked about, IoT is something which is going to bring the tsunami, okay, where the huge number of transactions going to come. And all these transactions with the certain SLAs, with the services, okay, it has to manage, monitored and controlled. IoT use cases, I think many of them we talked about it. I don't think there is a need to repeat it. Okay, smart cities concept which has come up, it has started in fact becoming a reality. Lot of even the cities where they have started practicing it. Okay, and there is a lot of business benefit, by the way, in terms of saving the energy. Okay, even the cities, how we can use our infrastructure and resources more effectively. Increasing number of global startups, I think it's a positive trend even for the India. Very good trend. We are very excited about it. Online transaction has made the history. Right? What we used to do it in the previous years, okay, where even all transactions through like currency transactions, okay, exchange of currency, okay, that used to be common. Online was very, very low. What has made during this even the tsunami, even just before even that COVID situation, okay, most of the transactions today are happening, okay, online, the digital transactions, okay. It has like created a trend, and it has created history in terms of number of transactions which are made online even from the India. Right? And there are other use cases. We have talked about digital classroom work and then remote healthcare. I think a lot of use cases we already talked about in detail. Now when we see what are the suite of services, what are the services at the end of it the customer is looking for, like we have heard about, we have practiced about it, triple play services, voice, video and data, right? Now we are adding one more term which is more of a surveillance and security services. It is very, very critical and very important, which cuts across all the three, okay, services, whether we talk about the voice services, okay, there are new security requirements even for the voice, the way being used and also being misused, okay, how the videos, what to use, what not to use, okay, there are a lot of policies and guidelines behind it, okay. Similarly for the data services and these various data services what we see, okay, some of these which are used to bring a positive trend, many of them in fact which is being misused, so there has to be a strict control about it. So surveillance and the security has become a very important as a fourth pillar, I will say, in the quiet play service. Very pivotal and very critical role. Now, we are also trying to see how this Quad plus plus and the other two major pillars what we are trying to introduce here is that IoT as well as the gaming. IoT, I think we talked about it. IoT is something which is going to in fact bring the killer applications. It is going to simplify our life. Let's look at today the way is like maybe some of the countries where they can afford a lot of manual activities even now, but we want to utilize this man force, okay, for little better things, how they can in fact do better things, they can contribute better if we can minimize the manual transactions. That is where the role of IoT applications comes, where most of the applications today where have a manual, semi-manual, okay, we are going to automate it. And that automation can happen once we bring interoperability among all the devices. So you have one device is one side, you have an application and content other side, you have a network infrastructure in between. Okay, how we can enable network infrastructure so that the device can in fact do the transactions, okay, with the contents, okay, at the other side. So IoT is going to be one of the major applications which is going to change the life. The way we have seen the transactions in the last 10, 15 years, similar trend is going to come very soon in the IoT space, okay, in next 5 years, I guess. Gaming is another application where Previously, we have seen, okay, gaming is something like, smaller, younger generation they used to play, but I think that trend is changing. We have seen even a lot of other people getting excited about the various games. And games is like application where what we see, it doesn't really matter what age the person is, okay? And where you are operating has no distance. Now all the distance has been bridged. Even the content, for example, giving available maybe other part in different countries, okay? But it really doesn't matter, okay? Where you are playing, okay? Where the content available, okay? And you can play the games on any device, right? So it is agnostic to devices what we use, agnostic to the location we are in, it is agnostic to the content we are using it, okay? All these contents, it becomes part of one ecosystem, okay? That is the one common trend which we see, and this is what is going to bring lot of data and lot of transactions even in the internet. Now, these quad or quad plus plus services had certain network characteristics, and they have certain dependencies, how they can be used and how they can in fact use while we can get a better experience. So what are the few critical, there are many factors, but if we talk about 4 or 5 of them, okay, for example, latency. A better game, yes, if the latency is lower, but latency is phenomena of physics, like is the speed of the light, right? Speed of the light we can't change, right? But definitely we can change some other parameters so that we can improve in the latency, right? Traffic engineering, even the network which is built up, no matter what level of resiliency which is built up, because every resiliency which is built up associated with a certain cost, right? It cannot be indefinite, okay, capacity and the bandwidth in the network, right? There has to be a finite, okay? So based on the services, based on like, we talked about it, even the 5G, multiple slices, and for each of the slice, whether dedicated resources or the shared resources, that is a discussion, okay, before lunch, okay? So all these is going to play a major role, and that can be simplified if we do our network architecture right, if we do the traffic, how do we take care of the different category of the traffic, and how do we treat different traffic which is used by different applications, how we can treat differently. That is what is going to make difference. For example, even there is a fiber cut as a phenomenon because a lot of development activity is going on in the country, and there is a fiber cut happening today, is going to happen even tomorrow also, right? So when we have these scenarios, okay, how we ensure there are certain characteristics of a service, how those services can be maintained no matter if there is a fiber cut happening, if the traffic which was going, for example, from Mumbai to Delhi, it was going via, for example, Jaipur, or it is going via Nagpur, how it should matter to the end user. As long as we build up, okay, network resiliency, how we can use some of these practices like traffic engineering so that we can provide same experience while we carry the traffic from one part of the network to another part. Guaranteed service delivery, I think this is something many of these protocols can handle it, okay? And if we have to ensure that any traffic which originated from one side, it has to be get delivered to the other side, okay? And it has to be delivered in the right sequencing with the right quality of services, right? So those quality of services becomes very critical. How do we build up resiliency in the network so that even one network element fails, or if there a link fails, okay, or any other failure comes in the network as an incident, okay, how fast we can recover, how fast we can restore the services, and while this transient change is happening in the network, in the field, how we can maintain experience of the customer. So we need to build up a self-healing network in such a way that services do not get impacted, okay, by change the network incidents. And many of the applications we see, they have certain characteristics, they have certain tolerance they can work with. For example, many applications, for example, gaming we talk about. some of the gaming applications, and that too depends what resolution we are working on the games. Okay, certain resolution. See, it can work very well at the 25 millisecond. If the latency is more, okay, application not impact tolerant. Okay, so we need to understand need of these performance parameters of each of the application, and then map those requirements in your network in such a way that when there is some incident happening, how we are ensuring that these services are not getting impacted. Now, while we have all these challenges, some of the solutions which we have, what we can do in the network? For example, this is just a representation of a network where we say there is a IP, MPLS network, you have access network, pre-aggregation, aggregation, core, and that is where in the 5G space we have seen front hall, mid hall, back hall, and then there is a mid hall you can play with, depends on the architecture, depends on the need, how you can play. Okay, mid hall it is becoming closer to the impact, back hall closer to the front hall. So the different practices, different technologies has a different design requirements. Okay. But what is more important in this is, okay, how we are maintaining latency. So if we cannot bring, effort is that how we can bring subscriber closer to your contents, right? Subscriber will remain wherever they are, right? We need to see how we can move our contents and go more closer to the subscribers. And that is the way, this is one of the mechanisms where you can reduce the latency. Of course, there are many other factors where what is the capacity which you build up, how much the utilization, when there is a failure happens, what is the level of redundancy which you maintain, how you are build up the QoS in the network, so that when the critical service is failing, how your resources are available so that you can take care of the critical services. So these are some of the mechanisms where how you can play and reduce the latency. And next is that, okay, resource redistribution. Right? When the network is small, we can have a centralized resources where it can take care multiple functions. As the network grows, subscriber grows, traffic grows, we need to see how we can utilize these resources more optimally. Right? Every resource which is deployed, it has to be utilized to the fullest. And that can happen more, depends how we can distribute this load. Okay? Need not to be a centralized nature. We need to see and distribute how we can resources, compute resources, we can, okay, distribute in the network so that it is, one, it brings the resiliency in the network. 2, it becomes closer to the subscriber. 3, it gives a better TCO where we are able to utilize the resources. They are not unused while we build up and spend money on this. Right? And I think third practice we say how we can upload these content toward the edge. Okay? If we are moving these content toward edge, again there is a trade-off. How much content you can move to the edge depends. There are many factors which can play a role. Okay, what is the subscriber, how much the traffic which we need, okay, how much is the minimum resources which needs to be deployed, and there is some capex involved on this. So I think there are many factors which play a role, and basically you can decide what content, where this can be moved so that it can bring a better experience to the subscribers. Now we have seen even network simplification we talk about. Traditionally we started like IP MPLS network where there used to be like practice where we say unified MPLS network, okay, LDP based network, all the provisioning happening through the CLI, okay. There is no programmability which is there, like it's fixed configuration, okay, of the network, okay. And we see how do we collect the data, okay, for monitoring and management of this. There is some mechanism. Services L2, L3 VPN services, we talk about LDP, BGP, the mechanism which you see, scaling mechanism where say, okay, level unicast using the BGP, and traffic engineering, FRR, which you have seen. This is the current trend. What we see when the going forward, when we improvise is how we can introduce, okay, even the segment routing in the network. Segment routing to bring one, it can guarantee the services, okay, it give a, in fact, no, experience with subscriber. There is a minimum changes, okay, when there is a network incidents which are happening in network, okay, and we can utilize resources more optimally. And there is change in the provisioning, how we provision. There is more net cost, young waste, in fact, no modeling which we use. SRPC, okay, model driven BGP, and more important in this IGP, using IGP, even the SR, we can deliver all these services what we talked about. So there is a change in the shift, the way we used to operate, and that new trend, how we are going to utilize even this technology to simplify and automate most of the functions. Now, while we talk about the scale, okay, subscriber, now, of course, it is the fact that, okay, we have a IPv4 which is a limited resource that is no more available. Even if we talk about private resources within the network for the private purpose, even that is also very limited and very small, okay. Now, we can increase, okay, even private resources, but there is always a limit, okay. So this use growth in the network, in the subscriber, if this is possible only with IPv6. And that is where IPv6 has played a major role, okay, how we scale the subscribers while we try to assign the IP addresses and connect to the network, okay. This has played a major role. And lot of contributions which are happening even from India. Even today, what we see, even the IPv6 number of subscriber and the traffic volume, what we even the originate from the subscriber today, okay, we have been like, you know, maintaining this highest subscriber, highest traffic, okay, globally. And this trend is going to further even increase. So this 5G IPv6, this is going to support multiple use cases what we see in the IoT. IoT primarily banking on, okay, mechanism for connecting to the network through IPv6 only. So the scale requirement is huge. M2M requirement is very, very huge that cannot be fulfilled any other means, okay. So IPv6 has become an enabler, okay, to give a growth both for the subscriber and also the network, number of network elements we connect to the network. So while we talked about various issues, challenges, solutions, what we can do, how we can bring and improvise the network architecture so that we can offer, or this network can enable multiple services to the subscribers, right? And we have seen even the trend, lot of pilots which are going on each of these business cases in the field, okay. And there is very positive trend which we see. There is a lot of excitement which we see even from the various business segments. When you talk about even the e-health, the e-commerce, even transportation, we see a lot of operators, even automobile industry, we are working with them, okay, where we are trying to simplify some of the practices what they have through the network. And some of these, like, you know, video, even the communication what we see, I think this is a common. And even the surveillance space, a lot of work which is going on, and the surveillance where everybody, like today, when everybody, no matter where they are on the move, they're traveling, but still they want to see from a security perspective, okay, they want to access the content, they want to see even the cameras at home, okay, how the security in place. So this has become part and parcel and very critical for every person. So with this, I will end here. I'll be more than happy to have the questions. Thank you. Yeah.
Very engaging presentation. Couldn't take my eyes off it. A lot of stuff that we talk within the interconnection industry is what I saw here. And that, you know, I couldn't resist from asking you this question. Your professional or personal opinion on the fact that we don't see Indian telcos in general and you all in specific, not being present on the fastest growing interconnection ecosystem that we see in the APAC region here. On both the sides, you see a couple of names. I represent one of them. My name is Sudhir Kundar, and I'm from INNOG6 India. Because I can speak for myself. We've seen some phenomenal growth happening in the last 3 years. We've seen the digital triangle as we propagate, while 5G on its own may not be of great help when somebody makes an enterprise investment. But when you marry AI and IoT into it, that's when the use case scenarios come into play. Gaming, I don't think there's any organization globally who wants to come to India doesn't consider us as well. And when I say us, I'm talking about the industry and not my company in particular. Or for that matter, CDN and VOD. So for example, on my platform, I can tell you last 3 years, we've seen about 3,600% growth on both these segments that I told you. And I can ramp up figures as I talk to you. Coming back and making it a very short, pointed question, again, is what are your thoughts on Indian telcos in general and your organization specifically, not considering to be on the IXs, which are growing by leaps and bounds as of now?
Okay, it's a good question, but at the same time, it's difficult too.
Yeah, that's why I asked. I don't ask easy questions.
See, when this, even the internet and the licenses to operate internet service in India, it was opened by the government. Right? Many of the business houses were very excited about it, and they have spent a lot of money, in fact, now getting the licenses, okay, as per the norms and regulations. They operated for a couple of years and decades, I would say, 7 years, 8 years, 10 years, okay. Now, while we look at it, at that stage, if I say awareness in the people, okay, and the affordability for the people to pay money, okay, to avail these internet services was really a very important criteria for a country like India.
True.
Where average ARPU, if you look at it, ARPU I'm relating with the affordability of the subscribers,
Sure.
okay, which is very, very low if we compare with any other developed economies, right?
Right.
So our affordability was very low. Although there was a lot of posts, a lot of infrastructure, a lot of investment has gone in the country to build up the infrastructure, create the infrastructure, and that has been operated, okay, for almost like 10 years, right? However, that awareness in the people, I think what we feel, my personal opinion, is that awareness in the people to sell them how important the information is for you, okay, to be part of the internet, where all these small things which you are struggling today is available outside. Only thing, we don't have access to that, right? So we could not sell to the end subscriber, maybe because of the awareness was not proper, or we did not put enough awareness. But the major part was that, okay, they cannot afford, okay, not everybody can afford even the services, okay, which comes like with the cost, okay. Fiber penetration was also not very high, right? So when we talk about fiber penetration was low, and then at that time I remember when we used to operate, in fact, even the network for a company, okay, we used to have like DS3 connectivity to the BT. We used to be very proud about it because we are the second largest internet service provider in the country, okay. So we feel very proud about. If you see the today's bandwidth, like now, it is like 100 terabits per second, which is happening, and there is actual traffic which is flowing, right? So there's a lot more changes are happening, and in this transition phase, okay, network was ready, but somehow we could not make our subscribers ready to, in fact, afford, or we could not address their need, in fact, how they can afford, how they can subscribe service, how they can connect to the network, so that they can use and get the benefit of this information, use information which is available, okay. And we also, I think, made a lot of effort. Government also pushed, okay, on this, and that is where I think, because of these stressing need, the consolidation begins. Okay, consolidation of the multiple operators has started because everybody competing and trying to look for customers who are very limited, and although it is a highly populated country, but at the same time number of customers who can afford and pay are very, very small. Everybody was struggling, okay? And somehow we could not manage that, we cannot, and that is where a consolidation begins. And when the consolidation begins, like, then many of these, in fact, the operators, somehow we could not continue because business model did not allow them, okay? And then consolidation happened, then 3, 4, 5 operators, okay? That depends on the state to state, somewhere in more also, that consolidation happens.
Sorry to cut you, actually, I'm on the same page when you're talking about all these factors, they are there. And I've seen the whole journey from selling a 32 kbps pack and SIFI way back 23 years back to what residential broadband user today claims to get 100 megs. That's a different story altogether. I maybe would want to re-articulate my question. My question was, knowing the way you are saying today that 5G and all other peripheral services which will be hitting upon services which are going to be consumed across the economic strata that we are currently serving as telecom operators, wouldn't it be sensible, and why is it that? I mean, I'm curious to know, why is it that the telcos in general and your organization in specific probably are not looking at onboarding at IXs? And I'm talking about it from an industry perspective and not from my own organizational perspective per se, because I represent one of the largest interconnection platforms across the globe and in India also. That's taking that part apart. Any thoughts on that is what I was more wanting to have your thoughts and opinion, whether it is a personal or a professional opinion, just to enlighten myself. Okay.
I think
telco वाले क्यों interconnection platform पे आना नहीं चाह रहे? Sanjay? नहीं, it's a question that is for everybody, sir.
I think
he can say no.
I think
let him answer.
I appreciate your question. I think there is also request. Okay, the next session is going to happen.
Sure.
So what I'll do, I think there are a lot more things which can be shared.
Sure.
Many of them may be relevant to you, relevant to other people, may not be relevant to many other people. So I think we can have a after
No
this
worries.
in fact one-to-one discussion.
I respect
detail,
your
right?
decision,
Yeah.
no problem.
Thank you very much.
Thank you so much, sir, for your session. Our next session would be a panel discussion for which we have with us our extinguished panelists. Can we have a great round of applause for Mr. Vivek Narayan, DDG Data Services from DOT Headquarters. Our second panelist, we have Mr. PK Singh, DDG Security and Assurance, DOT Headquarters. A great round of applause, please. Our next panelist, we have with us Mr. Rajesh Chera, President of ISPI and CJ Online. Great round of applause. We also have with us Mr. Praveen Sharma, Secretary of ISPI and Tata Communications. And our final panelist is Mr. Pankaj Chaturvedi, Treasurer of ISPI Lightstream. Once again, a great round of applause for our panelists.
Thank you. I must thank you, Mr. Vivek Narayan ji and Mr. PK Singh, especially in spite of their so much of busy schedule today, they were able to spare some time for us. And this panel discussion is not about anything, only about the compliances. That lot of compliances are getting requested from the DOT for the license holder to comply. What is the impact? What is the reason? And what is the difference between a category A player, category B player, and category C player? So we are discussing about that, so that lot of ISPs and regulators are, regulatory guys are here, so they will be well educated about these compliances, because anytime the compliance come, it come as a surprise. Thank you. So I will request to start with Mr. Vivek Narayan.
thank you for giving me an opportunity to address the gathering and clarify some doubts. We believe in ease of doing business, and we are trying to reduce the compliance burden. We have in fact done so, and we have met 3 of the demands which the industry had, that the upstream ISP would not be required to inspect the network of the downstream ISP. That has already been clarified. Then the ISPs which have central node catering to various LSAs are not required to be inspected LSA wise. They are to be inspected by one LSA where they are located. Other LSAs, if interested, can log in simultaneously via VC or participate in the same inspection, so the repeated inspections is not there. Then the number of inspections for Class A, Class B, Class B and Class C have been reduced. Then there is one more thing which has been done, is that we have requested all the ISPs to migrate to Saral Sanchar platform. The basic reason is that once you are on a digital platform, you upload your periodic reports on the platform, and then we can do data mining for policy formulation. So the data which is taken by DOT is basically to see and formulate policies or improve upon the policies for empowerment of the poor and bridging the digital divide. That is the basic reason, and I am highly thankful to all the ISPs that out of 1,600 ISPs who were not on the digital platform are today on the out of that 1,200 are on the digital platform. Thank you very much for cooperating with us and coming. So the remaining 400 ISPs I would request to migrate ASAP, otherwise we will be forced to take very, very stringent actions. So still I request that all those 400 who have not migrated, if they are not there here, obviously 400 people are not there, you may kindly spread the message that to please migrate, otherwise they will have to face consequences, because probably these are not active or they are not actively participating in the network. So, and we are also open to, in case any ISP thinks, then they can, through ISPI or through direct emails, they can contact us and say, ask us why this particular compliance. So we can either reconsider it or we can explain it to him what is the need of these compliances. But the basic requirement of the compliances is to formulate policies for development, digital development of India. Second is for the security requirements, which my colleague would explain better, and to see where India is progressing and to see which parts of India are actually having higher growth rate and which with regard to internet, especially in rural areas, and what needs to be done to promote this in rural areas. I have some more points, but based on the questions, I will deliberate on that.
PK Singh ji, अगर आप थोड़ा opening remark दे दें.
Thank you, and I would basically congratulate the organizers for arranging this conference and allowing us to have an interaction with all the stakeholders. So as far as the security compliance is concerned, we are basically very clear about it that minimum information, whatever is required, only that should be available for ensuring the security. Beyond that and above that, nothing should be requested, nothing should be ordered, and nothing should be provided by the service provider community. So that is the essence of compliance as far as the security requirements are concerned. And what we would appreciate is, I think it is better that we have an interactive session. Whatever are your concerns, whatever are your queries regarding the compliances and any other topic related with the security, we are here to address those. So without taking much more time, I think we should open up the floor for the questions from the audiences on any aspect related with the security or the licensing vis-a-vis the compliance burden, if it is considered a burden. Because as has been indicated by my colleague, Sri Vivek Narayan, the information which is being collected by the Government of India, it is basically for the improvement of the policies. It is for the improvement of issuing directions. It is for improvement of enabling the connectivity to the persons who are not having the connectivity. So those type of information, and only very minimal information is always taken, not that the entire network is being taken over or the entire network configuration is asked from the service providers. It is only what is the type of usage, what type of customers, where is the customer density, etc., etc. Those type of informations are taken, and then they are correlated in the background with a lot of other parameters and other information which are collected by other wings of our government, so that we are able to provide a whole of government approach towards revising the policies and tweaking the existing policies, and if required, doing away with the regressive policies, and in place of those regressive policies coming up with latest modern state of the art policies. Thank you. So we are looking for a lot of questions from your side so that we are able to satisfy your queries regarding the compliance vis-a-vis the licensing and the security and other aspects of network. Thank you.
Sir, may I, Pankaj here. Couple of things which some comments here. In the internet world, the technology is changing very, very rapidly, and we understand on the security aspects, the national security is supreme, and most of the crimes are also being committed on the internet now. So more and more stringent, compliances are going to come. My only humble submission here is, sir, that it's not something that we have complied to certain guidelines today and it will not change after 2 years. So from your good offices, we would urge that it's the security of the nation. It's not just that as a Class B or a Class A ISP is the one who's going to be responsible for the whole thing. The government needs to allocate a separate fund for such compliances, because it's a national security matter, sir. And we agree that we've taken a license, we've signed the license agreement with the Government of India, and such kind of things will continue to grow. So how is it that we can work together and see to it that we formulate a policy of in terms of the compliance with the support of the government? It's not that everything should come to the licensee, that since you've signed the agreement, now here is a license amendment, you comply. That's all.
Well, I'd like to answer that question. See, let us take for a specific example, like for providing IPDRs. Now, earlier it was only IPv4, now we are having IPv6. So earlier NATing was there, now NATing is not there. So we wanted the IPDRs to be stored by subscribers to be provided to the law enforcement agencies if and when required. So, but we understand that, say, for recording IPDR for IPv6 and for the complete, say Reliance has 40-50 crore subscribers. Jio has 40-50 crore subscribers, and a small ISP has 20,000 subscribers or 10,000 subscribers. So if you see the overall impact, the cost for Reliance may be 100 crores, so it comes to around 2.5 rupees per subscriber, capex. Cost for a small ISP may be 10 lakhs, so it would come to around 20-25 rupees per subscriber. So which is much more than the cost for Reliance. So what we did is that we asked CDOT to look into it, come out with a solution and help and handhold the small ISPs, and we also had a handholding sessions with the small ISPs, and I am very thankful to the ISPs that around 600 ISPs now have given us written compliance on IPDR. So wherever we understand that we need to handhold the small ISPs, definitely, because see, you are the ones who are empowering people who are bridging the digital divide. And see, with mobile, the number of subscribers are much more, but the data download per subscriber per month is only 17.1 GB per subscriber per month using mobile. Whereas using FTTH connections, it is around 250 to 350 GB per subscriber per month. So there is huge scope, and so the small ISPs have a long, there is a lot of scope for everybody, especially in the rural areas. There is hardly any penetration of the big players. So small ISPs have a huge scope also to work there. And we will continue to handhold the small ISPs the way asked for by the small ISPs or suo motu also.
Coming to the security related requirements like network security, network hardening, having an external auditor kind of requirements, particularly for the smaller ISPs. This becomes an additional significant cost. Can we have an alternative where these kinds of overhead costs, where the entrepreneur is the CISO, he is the CRO, he is the CTO and everything, having a small team, say, of 10 people, and he is serving in a district. So for those kind of examples, can we have a different template where we can have the same deliverables, but at a lesser cost? Is particularly related to more to category C and to some extent to category B also, sir. That was one part. Second part was a larger part where the friend from Jio already told that there is an 83% of video traffic, sir, overall internet. So when you talk either about monitoring or about IPDR or about anything, worldwide the trend is to have target-based monitoring kind of systems. Here we have 100%. Can we have a look at least not including that 83% video component, because that will significantly reduce the cost of all the players. So that was the second question, which was in respect of the monitoring aspect, sir, which Pankaj also raised in a different way. But what I'm saying is that the larger people will still bear the cost, but the cost can then be reduced if there is a redundant thing. If somebody is watching something on Netflix, that need not be monitored, because that record will always be there with Netflix itself, sir. So these are the two questions which I had.
Okay. Thank you, Praveenji, for asking this. In fact, when it comes to the compliance burden by smaller ISPs, let's say the category C and the category B ISPs, so it is not that we have a uniform scale which applies to all the three categories of ISPs. We have already done a differentiated way of taking information. In fact, class B and class C, they are not covered by the same set of guidelines by which the class A ISPs are covered. When I'm saying this, this is true in this in respect of the law full interception. There are certain conditions which, if are fulfilled by class B and class C, they are not required to establish a lawful interception system. They are not required to deploy a lawful interception system in their network. it is the responsibility of the upstream service provider who has provided the bandwidth to them, and the entire traffic is passing through their network. So it is the responsibility of the upstream service provider to have the lawful interception capabilities. So there are similar type of differentiated compliance treatment for the smaller ISPs. Now coming to Mr. Pankaj's question, wherein he has raised a very thought-provoking idea of, as far as the national security is concerned, government should try to own the majority of the burden for that. We do agree, and I would like to put across certain information for the benefit of all of you that the government is not shirking away from its responsibility. Government has taken a lot of steps which are probably not available in the public domain, and I would be pointing towards those type of activities which the government has already undertaken on their own without involving the ISPs, without involving or without enforcing a burden on the Class B, Class C, and even Class A ISPs. The first of all, we all are aware that it is the internet world, and the technology in the internet is evolving, and so is the way the crime is committed, that is also changing. There are many sites which facilitates the crime to be committed. There are many sites which facilitates a particular piece of malware to be loaded remotely on a particular end device. So a lot of such type of transactions, such type of communications, such type of informations, they are getting exchanged over the internet world. Now the end users, they probably do not have the capability. They are not aware of what type of protective mechanisms are required to be implemented by them, what type of piece of softwares, defensive softwares are required to be deployed by them, what type of network architecture they need to follow. They are basically not aware. So Government of India has already established Cyber Swachhta Kendra, which provides such type of advisories to all the end customers that this is the type of anti-malware which is required to be downloaded. This is a piece of anti-malware which you can download freely, and you can run, and you can scan your end devices, etc., etc. That is one aspect. Then another is how the government comes to know that a particular end device has been infected. So the government has already invested in determining whether an end device has been infected with a piece of malware. So that infrastructure has been developed by Government of India. It is not made known to the general public, but government has invested a lot in that. And once a particular end user device or end equipment or an enterprise network, etc., it gets infected with any type of malware, immediately the information is known to the government agencies, and they in turn issue advisories, targeted advisories as well as general advisories for taking care of such type of infections, and they even provide the tools to take care of such type of infections from these malwares. That is one part. The other part is, in order to keep our network free from such type of malwares accessing the end user devices, the Government of India has invested a lot in doing identification of these command and control servers and then taking action against them, which is not known in the public domain, but we have invested a lot. That is the second part to what Mr. Pankaj has said, that it is not that the government is not investing, government is investing. Now coming to your query, sir. As I was continuing that we have a differentiated methodology for treating the smaller ISPs from the larger ISPs. And we certainly, we had indicated that we are basically evolving over a period of time, and that evolution will continue to happen. So whatever were the policies available earlier, a lot of those policies have already undergone a modification to provide ease of doing business to all the sections of the ISP service providers. And if there is a need felt by the service providers that there is a further scope for some tweaking of the policies, the government is always open to such type of suggestions, and we are always committed to consider the genuine request from the service providers. And if those requests are made to us, they would certainly be considered. But I would always say that government, as far as collecting information is concerned, the information is collected to the minimum, and no extra information which shouldn't be collected is not collected by the government. Thank you.
Sir, a small clarification. You told me that for a smaller player, B and C, law of interception, you have given liberty that the smaller player doesn't require. But in that one condition is there that only one upstream should be connected to that smaller ISP. If we are looking at the quality of service which we are giving to the customer, we have to create a backup of the second upstream. In case one upstream is down, then the second upstream should be available so that the customer should not be isolated. So my humble suggestion and request will be the condition of one upstream should be removed. Why? Because we all smaller ISP, whether A, B or C, are taking the bandwidth from upstream provider. And upstream providers are totally monitored. It is a second monitor on the smaller player. Even all the content players are also getting monitored through the upstream provider. So my request will be to give actual benefit to the smaller player. Please remove that condition of only one upstream.
Okay. Yeah, see, we had indicated that meeting certain conditions, there is a differentiated treatment to the Class B and Class C ISPs as far as the lawful interception is concerned. Yes, you are right. For that, we will basically have to have deliberations and discussions with the industry to arrive at an appropriate architecture so that the information which is flowing in the network, there is no such information flowing in the network which cannot be monitored by the government and by the service providers also. It is not basically that the monitoring is from the perspective of the lawful interception, but the monitoring has to be from the perspective of that the information which is flowing is, and it should be a clean information which is flowing over the over the network within the country. So we basically have to have further deliberations on how to ensure that the information which is flowing, whether it is flowing from service provider A to service provider B or service provider C, and the service provider C or service provider B is only having a single point of connectivity, how are we going to ensure that the information which is ultimately reaching to the customer, to the endpoint, is really clean? So we basically need to have a deliberation on that aspect and discussions so that we can arrive at an optimum architecture wherein with the minimum point of controls or point of monitoring, we are able to ensure that the two requirements, first, the ensuring the privacy of communication, and as well as ensuring that the lawful interception needs of the government are taken care of first. Second, the information which is emanating and which is terminating from these endpoints is really secure, is not taking out or violating the user's interest. It is not taking out the user's commercially sensitive information. It is not impacting the user's interest. All those things are required to be considered simultaneously to arrive at an optimum architecture. And once we are able to arrive at that architecture, so whatever minimum monitoring is required, only that would be considered. Thank you.
Thank you, sir. Sir, in fact, just to take a cue from there, during our last meeting on this similar subject, I think we had requested that a demonstration can be done using the agencies, CDOT or TEC, so that setup can be made, that how the target monitoring can be done. So we'll request you that we can pursue that particular conversation and take it to the logical end as soon as possible. Thank you, sir.
See, the policies keep on evolving. Policies need to evolve. If a policy is a static policy, it will become stale and it won't be useful. So policies have to evolve so that they are able to take care of the needs of the time. And we are always open up to evolution of policies. So whatever inputs are provided would certainly be considered in right spirit. Thank you.
Rajesh Panwala.
Good evening, sir. Hello. Sir, in security, next set of MTCT guidelines are up for coming in the first week of July. There is some misconception or the confusion among the LSA officers. I had been talking to a couple of them. For example, the routers and switches are coming under MTCT guideline from 1st of July. So for all the purchases made before the 1st of July 2023 will be available for deployment till their life cycle till their life cycle goes on. What they are insisting is that from 1st July onwards, you will have to remove all the equipments which are not MTCT certified. So I need, a department should issue a clarification that for all the purchases before the guideline applies should be usable till it is existing. Otherwise, what will happen that if I procure anything in the month of March, I will have to throw it out on the 1st of July.
See, the MTCT guidelines are very clear. What it says is any equipment which is to be sold in the country, so before its sale, it is required to undergo a testing and certification. Okay, and you cannot have equipment which has already been deployed, and the corresponding essential requirements of that coming into force. Let's say you have deployed today. The essential requirements under the MTCT come into force, let's say 6 months after you have deployed. So it doesn't mean that after 6 months you will have to throw away this equipment and you will have to procure only the equipment which has been tested and certified.
Sir, but these
the guidelines are very clear, and if some LSAs are trying to interpret those guidelines in that manner, our request to the industry is kindly bring these type of incidences to the notice of Telecom Engineering Center, who is the controlling authority for the rollout of the MTCT. And if they are not able to help you, the TEC is not able to help you, Department of Telecom headquarters is always there, which will consider your request.
So that is why I'm asking, sir, send a circular at least for a proactive action, because
not required. See, if the government starts issuing orders and orders and orders, you will feel that there is a lot of compliance burden. We don't want to do that. You bring to the notice of the authority, guidelines are already there. The rules are already there. The guidelines are already there. The interpretation of those rules has been covered under the guidelines. And even if there are certain officers, yeah, there could be officers, okay. But the path and the process is already available with you, whereby you can represent to the authority and they would give the decision in your favor. Okay, so don't worry about that. If essential requirement is coming into force on, let's say, T0 plus X, so whatever equipment has been deployed during this duration is not required to be taken out at the X instance of time.
Right, thank you. And I have a small request to DDG-DS also. Sir, there is lot of things have been done in Saral Sanchar portal, but we still want some more things. Like even today, the TRAI reports are to be sent separately, although it is more of a same reporting, which we are doing it on the Saral portal. So you give the access to the TRAI also, and there is a Saras and Saral. There are two portals. Again, if you can merge, then CCA requirement also will be taken care by the same one single portal, rather than going to Saras with a different credential. With Saras, it is different credential. With TRAI, you have different login and different credentials. It is still a headache. So if you can merge all this, it will be a great help to the industry as well, especially for the small ISPs who are doing it like a single one-man army.
You will be happy to know that Saras and Saral are already under integration, and soon you will have one portal combined for Saras and Saral. The reporting module in Saral Sanchar is being improved. If you have any suggestions, please send me an email. I will have it improved. As regards the TRAI, let this system mature. Once it matures, so then we can ask TRAI also to consider, because TRAI is taking various parameters which they require. So let us do one thing at a time. Let Saral and Saras get integrated, let it mature, and then we can see if we can always give a link to TRAI for the common parameters.
Fair enough, sir.
That is definitely there, but please give your inputs on this. See, that is why the 400 ISPs who have not migrated need to migrate immediately. Otherwise, I will be forced to take stringent actions against them. So please spread the message to your colleagues who have not migrated to please migrate. Otherwise, they'll have to face the consequences.
Thank you, sir. Colonel R.S. Parhar.
I have got 2 points. The first one is, Pankaj just raised the issue of national security and getting information together, which is of national consequence. I would relate it now to from a citizen's perspective. Now today, you find every day scams taking place. And remember, all these scams are taking place on our telecom networks. And how they are picking up hundreds and hundreds of these SIMs, and they are able to further these telecom scams when we have got CAFs being filled, we have got confirmations being done, and we've got so many other things being done. So I just wanted to request the DDG Security, if there's something which is happening to stop these scams also, because this is now troubling the citizens a lot.
Yes, first of all, I would like to assure not only you, all the persons who are here, that a lot of activity is already happening on this aspect. And in fact, if you had gone through the guidelines which were issued on how the telecom service providers are going to get the customers, those guidelines were very clear, and if those guidelines were followed in letter and spirit, I am very sure these type of news incidences which you are referring to would not have been there. The guidelines are very clear, the guidelines are required to be followed in letter and spirit, but there are always dark sheeps which are not following those guidelines, which is resulting into availability of the SIMs with the malicious elements, anti-social elements, criminals, and government is really trying to work very hard on how to do a strict enforcement of those guidelines. Earlier, these guidelines were required to be followed voluntarily by the telecom service providers and by the entire ecosystem in the business of the telecom service providers, right from the person who sells the SIM to the end customer, then the distributors, from distributors, the telecom service providers, the officers of the telecom service providers, etc., etc. A lot of instructions at each control point were indicated and were required to be followed in letter and spirit. But since it has not happened, the government has been constrained to do a strict enforcement of those guidelines.
I'd like to add to that. I'd like to add to that 2 points. That your question is very much valid and appreciated. And the thing is that government is in active review of the present guidelines to enable automatic enforcement. And a department has recently developed a software called Astra, wherein we detected that the same person is having 50, 60 SIM cards, multiple SIM cards with the same person taken fraudulently. So that software has processed that, and we were able to detect that and take remedial measures. So these 2 things I am saying that the very soon you will see the review of the guidelines, which are much more effective. The guidelines are under review, and the Astra has also helped us detect the fraudulent people who are taking SIMs fraudulently, and then so that is also helped a lot. So we are doing acting in that direction.
My second question to DDG Security is, so we had a meeting 4-5 days back. It was a virtual meeting called by DDG of M2M services. And in fact, we were expecting your presence also, but somehow you couldn't attend that. And we missed having your experience and your suggestions on that in that meeting. So I just wish to bring one small point to you, is that the vehicle tracking devices that we are using in the country today, there are 2 types. One are open. You can buy it on Amazon, you can buy it, import it, do anything you wish. And the others are called AIS 140, that is Automotive Indian Standards 140. So the 140 standard are very stringent standards vehicle tracking devices, which are also designed to have 2 SIMs, eSIMs embedded into the machines. And also they are able to track the Indian navigational satellites, right? Because eventually the government's aim is to move away from the GPS systems and move on to the Indian satellite systems. However, the open system, these the vehicle tracking devices which are available in the open market, they are one which are fitted on the vehicle and one which can be planted on the vehicle. Now, we brought out in that meeting that these devices which can be planted, when I say planted means they have a powerful magnet, they have a eSIM embedded, they have a powerful battery which can give it life for 30 days, and this device can just be attached to any iron part of a vehicle, hidden part, and it will keep transmitting the location of that vehicle. Now, all these non-AIS devices, God knows where their data is going because there is no control. And most of the government departments, I am sorry to say, are buying these devices because of our 3 quotation system where the cheapest device has to be bought. So the cheapest device are these devices, while the AIS 140 devices are expensive, and Ministry of Road Transport has only mandated certain class of vehicles, that is the public buses, taxis, national permit trucks, and vehicles carrying hazardous materials to be fitted with AIS 140 devices. So now with these kind of devices sending data all across the world, I do not know actually, because when I did a little bit of research on this, I found that most of these devices are of one particular country origin. And they offer free server to them, to people, free application and server services if you buy that device. So result is that we are, this is a huge security lack.
We got the input which you wanted to make.
Yes.
And I'm sorry that I was not able to attend the M2M meeting.
Sir.
Otherwise, we would have initiated the action on it. But since you have brought it to our notice,
yes,
we would appreciate if input via email, etc., can be shared with us so that we can initiate, because it is basically not a problem which Department of Telecom alone is going to solve it. It is basically a Government of India approach will have to be taken on this. Department of Commerce will be there, surface transport would be there. A lot of government departments will have to involve and arrive at some common mode of action plan, and then only we would be able to take care of it.
I will just like to say two more sentences, sir. One of the easiest ways I found was that if the telecom companies make sure that the devices talk to only whitelisted Indian IPs. If the telecom companies included in their CAF that these devices only talk to whitelisted Indian IPs, the data will be stored on Indian servers. This problem 90% is over.
Thank you, Colonel Saab. Just one quick information. Both the gentlemen has come from the PMO program and they have to go back again to attend that program. Only one or two questions, so that quick questions.
Thanks, Mr. Charya. Anurag Bhatia, Hurricane Electric. This question is strictly in my personal capacity. In modern time, with all the encryption in place, with things like WhatsApp using end-to-end encryption and most of chat-based apps, at least using SSL, and the fact that SSL has become extremely easy, how useful is interception these days?
There are still a lot of antisocial and malicious elements who are making use of pure simple voice communications. Okay, the expert criminals, they might have migrated to social media and other forms of communication which guarantees end-to-end encryption. So you are very right. If we do interception, we may not be able to do a decryption of the content, but we always have the information about the metadata. So metadata is always available, and that metadata also helps us in analyzing and deriving intelligence about who the users are, with whom they are communicating, with whom they are in touch, etc., etc. So a lot of information also gets, a lot of intelligence also gets generated just by way of the metadata information which is not encrypted. Although we may not be able to do a decryption of the content in real time, but still we are able to derive a lot of intelligence. And to be providing a sensitive information here, government is trying how to do a real-time decryption of the encrypted content. So we'll certainly be able to do that in a near future.
Okay, sure. Quick 5 seconds follow-up. As I understand, the metadata would be useful in things like, say, WhatsApp call, which are going peer-to-peer. But as soon as you have communication going through a server, which is the case with, say, most of the chat-based system. So if I'm texting you, my IP is not communicating with your provider's IP. It's essentially going through whatever the provider is, the provider server. So in most of metadata, you will see end users speaking to these large cluster of CDN servers. So is that still useful, just out of curiosity?
Yes, it is still very useful. And we are basically going to have processes in place with the server providers, the WhatsApp owners, the Facebook owners, etc., so that they are able to provide us a lot of information about whatever we have intercepted by way of the metadata.
Okay, thank you.
Thank you.
Ramesh, a very small and last question, please.
Okay, okay, I'll try to be as brief. Sir, just small query. Even CDN providers today, they come in the country, take the lease line, or they take, in fact, now co-locate with the service provider and becomes part of the delivering the customer services. The part of the ecosystem start delivering customer services. What is the government view and the security framework available to comply with some of the governments, in fact, no, even the national security requirements in terms of, in fact, no, complying to latest, in fact, no discussion on the IPDR which is going on.
Yeah, see, from the security perspective, there are rules related to intermediaries, and the group of service providers, the group of enterprise which you have talked of, they basically fall under the definition of an intermediary. So whatever are the rules related with those intermediaries, those rules are required to be followed by those intermediaries. That is the first part. But going and taking a larger holistic view of the entire situation, the government is working on something which we may not be able to share as of now, but in near future, very short time, you would be finding a lot of new guidelines emanating from the government side, which will be taking care of the entire ecosystem which is getting developed and which is getting misused by the malicious and antisocial and anti-national actors. As far as the medium continues to be used by authentic, genuine customers for benign use, it is not a problem with the government. But once a system gets into the hands of antisocial, anti-national elements, then it is a cause of concern, and we have to take action at those times. Thank you.
Thanks.
I'd like to add something to it. See, TRI has given its recommendations recently, which includes recommendations on content delivery networks. So it is with the government, and government is considering those recommendations and would very soon come out with its decisions on the same.
Only a 5-second question, everyone.
Can I?
3 persons are there. 5-second question. Don't ask a lengthy question.
Thank you, sir, for the opportunity. IPv6 essentially is meant for public IP for everyone. So is it mandatory to record the flow logs such as source IP of the source IPv6, destination IPv6, source port, destination IP port, as per the current IPDR guidelines?
Yes, it is. See, we need the IPDR of the session, and session can be identified only by these 4 parameters.
However, in IPv6, each and every IP is public. Okay, so it is very easy to simply identify the culprit, because the purpose of sole purpose of logging is only to identify the culprit. So in IPv6, we can simply identify, okay, this is the subscriber. What is the purpose to go beyond that?
See, it is I can't start a technical discussion here, but if you see the IPDR format, unless you have these 4 parameters, you can't identify a particular session, and there could be multiple sessions. So the answer to your question is yes, but we can't go on a technical debate here because of paucity of time.
Thank you.
Sir, good afternoon. My name is Nikhil. So I'm actually raising a point, or probably wants a quick discussion around, or probably your suggestions around how we are actually differentiating the cloud telephony for enterprises versus the call center. There are a lot of guidelines in India for the call centers, but there are no set guidelines for the enterprises. Whenever you actually go trying to adopt a technology in the enterprise space, that puts a hindrance, because the OSP guidelines, which is very stringent and very detailed guidelines, which is set by the Department of Telecommunication, come and actually creates a roadblock for the enterprises, because it is always one powering the another to understand. Enterprises, on the other hand, are like free space, or probably you can actually go and adopt to the new technologies, but there are strict guidelines in the OSP spaces and the call centers that comes as a hindrance always. Is government doing something to ensure that like we move in the right direction in the voice network spaces?
The question which you have asked would require another conference of this nature, wherein we would be able to deliberate on all the points related with the guidelines for regulating the telephony with respect to making use of SS7 protocol stack versus making use of TCP/IP stack.
I mean,
One
the
quick
only
answer,
point
one
why I
quick
asked this
answer,
question is
one quick answer would be that Ring Central has recently come up with a solution of internet telephony basically for enterprises, and they have taken, which is mandatory required also, and they have rightfully taken an access service license.
and we are all waiting for their offering to come and hit the market so that others can learn from them.
In fact, one single line which we would like to inform all, that although the act is very old of 1885, but it still governs who can provide the telecom service and who cannot provide the telecom service. So whenever a person is trying to take a telecom service, the telecom service should be taken from the entity which has a license as per those 1885 Act and not from anybody else. Thank you.
Now, plus OSPs always had a special dispensation where they were allowed to bypass the telephony route. Enterprises were never given that dispensation.
It's a grey interpretation.
No, it's not a grey interpretation. Historically, it was only the OSPs who were given the dispensation that they can carry the telephony traffic over the lease circuits. And that's how the BPO industry progressed in the country. The telephony cost came down for them. Now to say that OSP guidelines are restrictive is a misnomer in my view, because OSPs are permitted to do that, enterprises are not. Enterprises are basically consumers of telcos, so they'll go by the normal route. So because of internet telephony coming, which is a non-geographic service like Ring Central was spoken about, so they may have different kind of tariffs because internet telephony is essentially a non-geographic but a carrier grade telephony. So it's something like Microsoft Teams giving services in India.
I didn't want it to name it, but
So
that's exactly
something
the
like
kind,
that,
yeah.
something like that, yeah.
The last question and very small question, please.
So my question is, as an ISP, we used to get URLs of HTTPS websites, and we need to block it as per DOT guidelines. We do not know how to block the HTTPS websites. If we cannot inspect the HTTPS data, how it is supposed to be completed?
The whole website of HTTPS is to be blocked, not a particular page of the HTTPS website. You can obviously block the whole website.
Actually, sir, we used to get the URLs, not the website address.
No, who is giving you? I am not giving you. Or from DOT, any blocking guidelines I am issuing, and I am not issuing any such guideline. You can show me any such guideline issued by me.
It is, past there were some Twitter pages or some sub pages which were of HTTPS nature, which were asked to be blocked. So we always used to respond that technically it is not possible. But when it comes to blocking the entire web page, a particular entire website, then by DNS blocking it is possible, although it is very much ineffective. As is the any information blocking, whether it is HTTP blocking also can be bypassed by using VPN-based routing, all other kinds of browsers which are available. So, in fact, what I wanted to say is that internet blocking of the information on internet, blocking of content on the internet should be done by the people who are hosting the content, who are aggregating the content, who are responsible for the content, and not by the ISPs. ISPs unfortunately have become the blockers of the first resort because we are the only licensed players available for the government to issue such orders.
Very soon I am going to discuss with the ISPI very soon, and within 3 months we will have some guidelines on this.
Sir, last question if you allow me. I won't take more than 2 minutes. Including the answer from sir. So the question is directed toward you, PK sir. IPDR, whom should I provide log to? There are 15,000 police stations in India. Are we supposed to respond to any and every query on our email?
There are designated nodal officers of each LEAs. request would be coming from them. A request would be fulfilled to them only. Thank you.
Thank you, sir.
Sir,
There
एक
is some
small
streamlining required here, sir, because we get lot of mails from thanas, especially, sir. ये block कर दीजिए, वो block कर दीजिए, block this website, block that. Under Rule 79(3)(1), quoting all of that, and then they say block this, block that. This is pornographic, this is obnoxious, this is that. So all these orders are still coming. Orders to get some IPDR information are coming at the level of, and we do not have the authorization for all of those people, sir. I am sending it to my person who is dealing with the police, and God knows whether he complies with it. Generally, he would be complying because police orders are generally complied with. So, but there needs to be a discipline there, sir, that for each state there has to be somebody authorized who need to converse on mail with the nodal officer of the ISPs. Thank you so much, sir. So that's a point which can be taken.
Sir, on behalf of Category A ISP, a small query, like the trusted portal compliance are being asked by the department. Now the department has sent this compliances to all the term cell for compliance. Now what is happening for a Category A ISP, every term cell is asking for the compliance and the same compliance, and they are saying that no, सेंट्रल LSA में देने की जरूरत नहीं है, आप मुझे दो, वरना it will be non-compliance. सर करवा दो. Thank you very much, sir, for coming on this busiest scheduled day, and we are really obliged.
And with that, we successfully conclude our panel discussion. Can we have a great round of applause, please? I would now be requesting Mr. Rajesh Charya to kindly felicitate our panelist, Mr. Vivek Narayan, sir. Can we have a great round of applause? We are presenting them with the Mithila Lok Chitra Kala, a Madhubani painting, as a token of appreciation and effort. And now I request him to please felicitate Mr. P.K. Singh. Once again, can we have a great round of applause, please? I thank our panelists once again for sharing with us their valuable knowledge and insights.
Just a small, few days back, there was an ethnic EC election. And from ISPI side, we have nominated Colonel R.S. Parhar, who won the election with a good number of votes. So I will request Colonel R.S. Parhar, because you guys have voted for him from the India, so it's his duty to thank you also.
I take this opportunity to thank the complete Indian community. I am extremely grateful to Mr. Rajesh Charya, President ISPI, the office bearers and the Executive Council of ISPI to have reposed faith in me, and they put all their heart and soul into getting the votes together from India. And I am also extremely grateful to various government agencies like BSNL, NICSI, NIC, EarNet, and others who also contributed in their own way by giving their votes to my standing for the elections. And it was a singular honor, and I promise to uphold the Indian flag wherever we go, and make sure that our best interests are kept at heart. Thank you.
Thank you, sir.
And with that, we will now take a short tea break. As we're already running behind schedule, I would request you all to kindly reassemble after 10 minutes. And I would once again like to highlight our sponsors for this event, our diamond sponsor, Tata Communications, our gold sponsors, AP, NIC, AWS, our silver sponsors, Alliance Broadband, SIFI, Spectra, World Phone, Nixie, and Equinix. I once again request you all to kindly be back in next 10 minutes. And once again, I welcome you all to our last leg of sessions, and I welcome you at INNOG6. Moving forward to our next session, we have with us Dr. Satya N. Gupta, who's the Chairman of Board of Blue Town. Can we have a great round of applause, please?
Thank you, madam, and good afternoon, everyone. It's indeed a great pleasure, honor for me to come here, especially in our community of ISPs. I was there, of course, about 10 years back, actually, I was involved, so it is homecoming for me here in ISP. I went in INNOG and also in IIT Delhi, actually, after my post-graduation in 79. I did internship in a department of this IIT CARE, Center for Advanced Research in Electronics. So it's indeed a pleasure. My presentation, of course, will be slightly different, not technical in that case. And I saw you were discussing IPv6 already. The experts from DOT were already there, and I think you know. From your questions, I gathered that you know it all, actually. And that will help me, actually, because I am coming out of another conference and I have to go back there, and otherwise also time given to me is 15 minutes, and that is more than enough for me. So what I want to bring out is convergence of IPv6 and blockchain, two things, not just IPv6. Blockchain, as you know, distributed ledger technology, which is making waves these days, and it has a lot of things to offer to the internet community also, to the web also. Like when you call web 3.0, without blockchain, web 3.0 cannot happen. Same thing, a lot of security thing blockchain can provide it. And that is why I have called it towards future secured public internet infrastructure. As you know, whatever you say, whatever we talk, the public internet infrastructure, they say, is not secured. That is what, and that is what we are working on, and your network operation group also has to work on that. So that is what I'll try to bring to the table, but I don't know how it works with this. Yeah. So there are a lot of things I'll be skipping because this audience knows it all. You know what is IPv6. It is also called new internet, and what advantages it has, I think I don't have to repeat all these things. The two things actually, because you are from network operation group, the end user perspective and the network manager perspective. End user perspective is he wants everything, all the apps, end-to-end connectivity and at almost free. That is what is the user perspective, and that is why internet is normally free kind of thing. But network managers, they have to provide stability, reliability, security of a given technology, implementation benefits, and cost of deployment and operation, because service has to be provided at a negligible cost or almost free. So there is a conflicting perspective from the network operator, and this of course I'll skip, and this is what I'll like to show. IPv6 key enabler of the e-economy and work from anywhere. Like post-COVID and during COVID, this concept became a big thing where internet showed actually that if you can make internet to work everywhere, then you can work from everywhere, because these days without internet you cannot work. And if you are working, that means you are connected to the internet. So that is what we call work from everywhere, and government in their wisdom with great difficulty permitted these call centers and OSPs agents who were to sit in the office actually to do any work for a client who wants his data to be protected. So work from home was a very difficult thing and cumbersome thing actually. If you have to take a permission to work from home at a data center, so you need some license, OSP registration was there, bank guarantees were there, and then you have to take what is called a leased line or VPN, which is very expensive. And when you permit anybody to work from home, he cannot afford to get VPN, and VPN may not be available or a lease line. So from a public broadband connection, you have to create VPN of your own. And if you have to create VPN of your own, that is called customer provisioned VPN, so you need a IP address. And when you talk of V4, you know that there is a NAT and everyone cannot get a dedicated IP address or a static IP address. So that is what IPv6 helps actually. Here you can give to anybody, and that is how it all happened. There are a lot of applications which we will not go actually, though this has like work from home, I mentioned virtualization, cloud computing, but IoT. Actually, IoT is another field which have to integrate with IPv6, blockchain, 5G, all these things put together. Actually, this presentation is just to show what are the different technologies they have to interact, converge together, so that you get what is called Web 3 actually, and I've given it a different name which you will see here. So this is IPv6 and 5G. 5G have network slicing, as you know. One network can work, you know, a different type. Like one can be only for high speed, other slice can be only for low latency, third slice can be for the high density. Then there can be a slice, one only for health, e-education. So your network can be sliced. So if network can be sliced, more IP addresses will be required actually. So that is where, and so this is 5G and IPv6 convergence is already happening. But what I want to do, and especially it is worth mentioning that where we are actually, as you may be knowing, what is the rank of India in the deployment of IPv6 in terms of number of users. Though I've shown this slide to you, but it may mislead you. I'm talking about rank of our own country, India, in the term of the number of users of IPv6. So you should be happy we are number one actually. In fact, 50% of the IPv6 users are from India. The numbering about 450 million. The IPv6 users are about 850 or 900 million. We have yet to become 1 billion IPv6 users. But of course, there is a adaptation kind of thing, or the capability. In capability also, if you go by percentage, we are number 2 after France. That is the capability of your service provider to provide you IPv6 connection. So this is what I have taken from Cisco. In India, of course, now I will skip a lot of things because IPv6 initiatives happened in India long back actually, and that was about 20 years back. A lot of initiatives, a lot of government, industry association, and finally we have come to this level. So I'll not be going to all the detail. You already, someone would have told you economic value of IPv6 in India. The strategy was something unique what the country did through their national telecom policies, the 2012, then NDCP 2018, and now there is a deadline actually which is already over. The government told each service provider or each website, each network should have become dual stack at least, IPv6 and IPv4 by December, which have just gone. And we may be almost there actually, you people will know that. And there is a similar deadline was set up by government in USA, and USA, that deadline is more like a sunset clause actually. They have dictated that 2024, everything will be V6, not even dual stack. It will be V6, 2024. The order passed by their president. So that is what you can see the future of V6. So this is how it happened in India. A lot of work was done by industry. All these task forces were headed by the industry. Normally, government people likes to head a task force. Here only oversight committee and steering committee was headed by the government. There were about 10 task force. They were headed by the industry. And that is how all these things happen, and the status is again. Now, the main thing which I want to bring here, where blockchain will also pitch in, is the how you can improve the security and reliability. If you want to have a secured public digital infrastructure. So the security is one thing, because whenever we talk of internet, oh, it cannot be secured. That is what first impression comes to everybody, including technical people actually. That is what is called cyber security issues actually. But with IPv6 actually, and you know IPsec is there in v4 also, but in v6 it is almost built-in kind of thing. It is almost mandatory, and it is more powerful. And more than that, IP6, there are two more facilities. One is called AH, authentication header, which can also encrypt, not exactly encrypt, but can timestamp your content itself. So the content itself gets secured actually. And same thing is this ESP, encapsulated security payload. This is a very powerful thing comes built in the IPv6. If we can make both of these as a part of IPsec protocol, so we can really make the internet also secured actually. And then absence of NAT, they were talking about absence of NAT, what it can do actually. End-to-end connectivity if you want, end-to-end traceability if you want, then NAT has to go away. And if you are with v4, you cannot do away with the NAT actually, because the addresses are not enough where you can give address to each and everyone. Then there is another thing, and that is what may be new to some of you, blockchain-based CGA. I'll be coming to blockchain immediately. Cryptographically generated addresses, which prevents spoofing, which prevents phishing, and also they can make your address itself sort of pseudonym kind of thing, pseudonymous kind of thing. And all these things together actually can make the internet more secure. There is another thing, and that is my personal thing, of course, IPv6 root server for India and BIMSTEC nation actually. And there is a thing, and there is a case actually, and especially when you go for V6, to have a geographically distribution of the root servers. As you know, now there are 13 root server authority, 10 in US, 2 in Europe, and 1 of course we have in Asia, but only 1, and where it is in Japan. So where more users are there, more content is likely to be generated. So it should be having its own root server geographically concentrated or located there actually. But in the V4, you may be knowing because you are all technical people, it is not possible technically to have additional root server. That is what we are given to understand. You may be knowing better. So, but in V4 such restriction is not there. There is that IETF RFC is there, which actually tell how to design, develop, and create a root server, a DNS root server. So we should be reading that and trying to create one, because there is no technical problem in having a root server. But that is a different debate, of course. It will help lot of things actually if you have one, and so that you would ensure DNS query and discovery is resolved locally and hence efficiently and speedily. So this is what but blockchain, now I'll not go to the basics of blockchain, I'll just come to the convergence side. Blockchain is also called Internet of Value. It is depend on these 5 pillars: public, private, cryptography, hash function, database technology, decentralization, consents, all these things together. And it is like OSI model, we have 7 layers, here we have 5 layers, and that bottom layer, which is hardware and infrastructure layer, actually is the existing internet, because blockchain is also internet of value. So it works as a over the top over the internet. So other 4 layers are there, and That is how it happens, but immediately I have to come, and this is new thing which I wanted to bring, IPv6 with CG and Bitcoin, you know, that is one of the application of blockchain, and it can prevent sweeping of a valid CG address, because the address itself is cryptographically generated. It is not allocated like what it is done at the moment. So it can be safe. And this is what next actually, what I wanted to bring to the table. Blockchain, AI, IoT and IPv6, if all of them put together and then you come in the center, that is what will be called Web 3 actually. And I will just see Web 3, and this is what my own reading of the Web 3. You already know Web 1.0, Dr. Tim Lee, that was about 30 years back, and that was just a static kind of web, static. It was not interactive, it did not have the videos. And then we came to Web 2.0, which we are there now also, read, write. The earlier web was static and read-only web, and now we have read, write, collaborative, video, search, all these things are there. And now we are talking about metaverse. I will like to put it as a Web 2.5. It is not fully Web 3, and you will see the difference. So here it is read, write, immersive, three-dimensional, virtual, cognitive AI. So this is also having almost everything. What it does not have is the ownership. Here the ownership of the content, like in Web 2.0, so Web 3, Metaverse also, it is with the technology company or those people who invest in the infrastructure, but not the user. Now why you should go to Web 3, and what is Web 3? Web 3, the difference is, it is read, write, own, the ownership part actually. So own means whatever you put on the internet or web, you are owning it. You can monetize it, you can delete it, you can update it, whatever. It is your content, you are the ownership. If it is generating some money, it is your money. That is why I will like to call the Web 3 as Internet of Owned Wealth or worldwide owned wealth, because it is your own wealth actually. And that is what it is, like a virtual digital public goods. So that is what we have to see. And how it is made possible? It is made possible by the decentralization facility or characteristics of blockchain. So if you use blockchain, then you can decentralize everything, even the ownership. There is no centralized authority here. There is no centralized ownership of anything. So that is what I wanted to bring. And of course, there are a lot of things have to happen, capacity building, skill like research, and these things are happening. But they have to happen specially for the internet. And this is what all has happened. One thing only, and the last line I like to read, that is the caution. You know, there is a talk about that internet is broken because for IoT, for M2M, for number of IoT kind of application, it cannot help and it is totally unsecured. So we don't agree with that. It is not broken. Actually, only thing is we have to make use of full facilities of IPv6. So there is a saying, don't try to repair something which is not broken. That is what we are here. Instead of that, you upgrade it to IPv6. So that is what I want to stop here. And I'm really thankful to all of you and for Rajesh ji to give me this opportunity. Thank you. And I will have to leave also. I'll need your actually leave also. Yeah. Thank you. Thank you.
I would be requesting Mr. Rajesh Sharia sir to kindly felicitate our speaker as he would be leaving immediately. Can we have a great round of applause, please? Moving forward to our next session, I would now take this opportunity to invite Mr. Samit Jana, CTO, WorldLink Communications from Nepal, to please come on stage and deliver his presentation. Can we have a great round of applause, please?
Not needed. So finally, opportunity to speak after a long wait. So first of all, I'd like to thank INNOG to giving me opportunity to come and present update about Nepal, your neighboring country. So I would like to shift a gear here. So we had a lot of technical sessions. So here I'm just trying to explain what we are doing in Nepal and how we are building, operating, and network. So without wasting any time, so I would like to move forward. So basically, just a quick facts of Nepal that, right? So we have a population of 30 million. We are a very small country, and we have a total household of around 6.6 million. Literacy is roughly around reaching 70%. GNI per capita is right low. GDP growth is also low, around 5.8%. Interestingly, the internet penetration is really high. So mobile penetration is already reaching 94%. And you see that fixed broadband is already reaching 36%. And this is considered one of the highest in Southeast Asia. And this is predominantly driven by private ISPs, bringing fiber to the home in the country. Nepal is a very young federal democratic republic in 2008, and we are a landlocked country. So briefly talk about Nepal telecom sector. We have around 130 licensed ISPs. Out of that, around 45 are active. So we have 22 licensed NSPs also, network service provider, but out of them 10 are active. Then we have 6 licensed mobile operators, but 2 are active. Then we have cable operators, a few hundreds are active. Then we also have commercial data centers, 6 commercial data centers, 1 internet exchange. We have 38 million mobile subscribers, 2.4 million fixed broadband users. Then we have, out of that 2.4 million fixed broadband users, we have 2.3 million FTTH connections. Then we also have IPTV services, so around 550K IPTV subscribers we have in the country. Then we also have some portion of wireless connection that provides connectivity to the rural part of the countries. Around 2.7 million digital DB, which is shrinking gradually because of the uptake of IPTV. Then traffic, at present we have around 1.8 terabits of traffic, internet traffic that goes that comes inside the country from predominantly from India. Then within Nepal we have around 10 terabits of traffic. This is roughly north to southbound traffic, not the east-west traffic. And ISPs are at present focused on building access network. So we want to build the access network and connect all the homes in the nation, in the country. So the fixed broadband drive is being driven by basically the ISPs, and it is predominantly by FTTH. So to talk about my company, WorldLink, so we are 28 years old company now, and we have roughly 3.7 million internet users. We are the leader in fiber to the home in the country, so we have roughly 760,000 subscribers. Now to just fast forward, so traffic we have around 33 terabits per second, and we almost cover 95% of the districts in the country. In terms of market share, so 35% fixed broadband market share we have in the country, and we carry 35% of the Nepal internet traffic. Now, to talk about internet exchange, because I am also a board of director of Nepal Internet Exchange, so I just want to briefly talk about Nepal Internet Exchange. So it was established in 2002, and Nepal's first and only internet exchange. We have around 53 members at present, and we operate in 3 different parts of the Kathmandu. So point of presence are around 3. Traffic roughly peak 100 Gbps, which happened in last World Cup final, but in average we see around 25 Gbps of traffic. So these are our websites, and we also host several SANOC, and we have also hosted Apricot in 2018 in Kathmandu. Now to talk about Nepal operators groups, so similar to INNOG, we also run NPNOG, and it was established in 2016. We do 2 programs in a year, one in Kathmandu and another outside Kathmandu. So total so far we have done 7 events, and the format is similar, workshop and one-day conference. So average participation we see around roughly 250. So we have a website also, so if anyone is interested, you can just go through it. Now to talk about the connectivity and access technology. So internet in Nepal started, not internet, so basically email service started in Nepal in 1994. And then the launch of internet service happened in 1995 using 64 kbps of lease line to UUNet. And then in 1996, we started dial-up internet service, but this time with a VSAT backbone connecting to US. Then in 1997, the first Indo-Nepal optical fiber connectivity happened, but that was not used for the internet. It was basically used only for telecom service. But surprisingly, in 1998, we had the first Akamai cache server in the country, and we were probably the first country in South Asia to have the Akamai at 1998. In 2000, Nepal Telecom started dial-up services, and others, ISPs like us, we started fixed wireless broadband. We used Motorola Canopy radios at that time. Then in 2001 and 2003, because the radio technology that we were using, Motorola, was very, very expensive, and we wanted to make the internet affordable in the country. So the ISPs started using cable and unmanaged Ethernet-based internet service. So basically what we used to do is we used to mount a small low-cost switches in the electricity pole and used to pull Ethernet wires into the homes. So that was during 2000 and 2003, but we could not continue with that access technology because Nepal were experiencing huge long power cut at that time. So operating and managing it and keeping that network power up was really, really challenging for us. So we have to go back to wireless again in 2006. And 2006, there were a new company called Ubiquity Networks were there. So we used their equipment to provide low-cost wireless broadband service in the country. Then finally, in 2007, 2008, the Indo-Nepal optical fiber connectivity happened, and the private ISP did that. And from 2007, the internet in Nepal started flowing from optical fiber. Then in 2011, the first Nepal-China optical fiber also established. So, but it's not being used because that segment was really unreliable. So even till that, most of the traffic flows through India, not from China. Then in 2011, we had a first Google Edge cache node in the country. Then in 2012, we upgraded our unmanaged Ethernet-based internet service to managed-based full-fledged Metro Ethernet service. And from 2012 onwards, we started to provide speed up to 10 Mbps at homes. Then from 2013 onwards, fiber to the home started in the country. So at present in Nepal, so the overall country's broadband growth is driven by FTTH, right? So 95% of the fixed broadband connections are at FTTH, and it is highest in South Asia. The major contributors are there, so there is no right of way. So any ISP can just pull the fiber if they have a license. There are no regulations. And we had a really stable and scalable backbone network. The network infrastructure cost keeps on dropping every year, and there is a huge surge in data demand for the data, and extremely low fixed broadband connection. So these major contributors contributed to the growth of broadband in Nepal. So FTTH is replacing all other broadband technologies, cable, metro Ethernet, wireless, and everything. So, and at present in the country we have 7 million home passes, and the port occupancy are roughly 30%. The average RPU we see around $8 per month, that's including IPTV, and this is also one of the cheapest in the world. Average speed we provide around 200 Mbps, and we provide a speed up to 1 Gbps. And fixed wireless access still remains the only access technology in the rural part of the country, because it's very difficult to pull fiber in the rural part of the country. Airtel and Tata are still two major IPTV providers as on date. So these are the CDN edge cases in Nepal. We have Akamai, Google, Meta, Facebook. Then we have ByteDance, Netflix, Tencent, Cloudflare, and this Huangshu and G-Core Labs. So these are the major CDN cases that are available in Nepal. To talk about a cross-border point, so majority of the cross-border point you can see, so it comes from a place called Bhairava, which connects to the Sonauli of India, and from Birganj, which connects to Roxol of India. So, as I said earlier, Airtel and Tata are the major IP transit provider. So we also have a connectivity with China Telecom by a place called Raswagadi and Tatapani, but it's there, but it's not being used predominantly. Now to talk about traffic profile. So we see that almost 75% of the traffic being consumed by Google, Facebook, and ByteDance alone. So you see that Akamai is 8.2%, but that also includes ByteDance traffic. So it's a huge social media traffic that we have in the country. You can see that rest of the CDN traffic, it's very, very minuscule compared to what ByteDance, Facebook, and Google has. To see country-wise traffic, so yes, so most of the traffic in Nepal comes from Singapore, then from the United States, then from Hong Kong, and then from Europe and other part of the country. So from India, it's very, very few. It's 6.4% that we see in the country. So we recently established peering in India. So we have built the infrastructure up to major data centers in the country through our partner. And this is what we see. So we see around 50% of the traffic coming from peering and 45% from IP transit. We expected that it should be 70-30, but it did not happen because Nepal still watches a lot of Chinese content, especially TikTok, and it's been removed from India. So those traffics come from Singapore at the moment. So in peering, Google and Facebook are the major contributors, then Amazon, then followed by Netflix and so on and so forth. And on the IP transit side, is ByteDance almost consume half of our IP transit today. To talk about IPv6, so roughly around 36% of our users have IPv6 capable. And in terms of traffic, IPv6 still carries 69% of the traffic, and IPv6 still carries 31% of the, sorry, IPv4 carries 69% of the traffic, and V6 around 31%. So there are a lot of challenges that we face, that we see, so, and we come across during building a fiber to the home, even in urban and rural part of the country. The first foremost thing is the high capex and OpEx, right? So because everything that we import in Nepal, it comes from abroad, and the USD price keeps on going and going. So that's why we have a very, very high capex. And because the infrastructure is poor, we also spend a lot of in-app OpEx. And because there were no regulations, so every service provider can pull the fiber as long as they have a license, so it's a mess. So when I say that we contribute 33% of the market share, so 33% of the mess also we created. So this is one of the big projects that we will be doing going forward to clean this up. But it's not that easy. So yes, so Nepal is very diverse, right? Difficult geography and terrain, so it's very difficult to build the network there. And sparse settlements also create issue. Low population, very low population per square kilometer. obstruction by local cable operator because their business are going down and they are now converting from cable operator to ISP. So when we pull the cables and we lay the fibers, they create a lot of hurdles. Then of course, yes, natural causes like fiber breakage due to bushfire, storm, floods, landslide, vehicle accidents. Those also create fiber breakages. And at the rural part of the country, there are no poles to lay the fiber, so we have to erect our own pole. That also add cost. Then when there is outages, there is a long restoration time. A logistical issue like transporting and arranging adequate spare equipment is very, very challenging. So it's maintaining high availability, it's a very, very difficult task. So what's the impact? So you see that still 15% of the area connected by ISPs, either fixed broadband or either fixed wireless broadband or fiber to the home, still do not have mobile coverage. So we are the only, so internet is the only means for them to communicate with the outside world. And even in some villages, they saw the vehicle coming into their village for the first time, and we were the one who took that vehicle. You see it in this picture, it's been transported through the river, right? So, and in many places we also need to build our own road to take the vehicle. So many villages also use internet for the first time, right? And several life-saving rescues also made in those parts of the country when the internet access were made available. So, well, I will be on time, don't worry. So it has helped to reduce the digital divide in the country, created local employment because when we build the network and operate the network, we give employment to the local. And it has reduced the migration. So brain drain is also a big problem in the country. So young people doesn't want to stay in the country, they want to go abroad. But at least when the internet is available in the rural part of the country, that gets reduced. Then it has helped to enable e-governments, e-commerce, e-learning, e-health. And the most important thing is connected families because Nepal is now largely dependent on a remittance, right? So most of the youth are working abroad and they want to connect with their families. So it has connected families. And of course, it has also brought the happiness. So building and operating a network in Nepal is immensely satisfying. So we are very proud to be a forefront in the journey to reduce the digital divide in the country, and we are very proud of it. So with this, I will rest my presentation here, and thank you so much for listening. And I will also take this opportunity to welcome you all in INNOG6 between June 18 and 23 in Kathmandu, Nepal. So welcome you all. Thank you so much.
I would be requesting Mr. Rajesh Charya sir to please felicitate our speaker, Mr. Samit Jana. Can we have a great round of applause, please? I also invite on stage Professor Huzur Saran to please come on stage. Can we have a great round of applause, please? He was also a speaker in the earlier session, but we missed out on felicitating him. And with that, we move on to our next session. I would be inviting on stage Mr. Anurag Bhatia from Hurricane Electric to please deliver his presentation. Once again, can we have a great round of applause, please?
Right, good evening everyone. Some fun technical glitches. It's kind of fascinating how IP technologies have grown, but HDMI is still so buggy. Anyways, I'll be talking about IPv6 and internet infrastructure, and this would be a quick talk. Probably I'll try to finish it in 20 minutes or so, since we are running late on the program. Quick background, my name is Anurag Bhatia. I work at global IP backbone provider, Hurricane Electric. We do IP transit. We have networks in around 46 countries as per last count. We are at over 270 plus exchanges right now. So it's a fairly large multi-terabit backbone. I spend a lot of my personal time in looking at BGP routing table, doing trace routes, putting out internal tools, and so on. So with the background out of way, where do we stand in terms of IPv6 deployment in 2023? So I'll start with the 3 questions to make sure you all wake up. Probably everyone would be tired. How many of you have heard of IPv6? Can you please raise hand? Okay. Quite a bit. Do you use IPv6 on daily basis? Can you raise hand? Okay, for everyone who has not raised hand, are you using 4G or 5G from Jio, Airtel, or VI? If yes, then you are using V6 for sure. How do you know? Well, you can go to, you can open your phone and go to bgp.he.net, and you'll see your IPv6 address. This tool will show you the IPv6 address from which you are connecting, and that would confirm. If you still want to be sure that your device actually has a native V6, you can look at any of the apps. So for instance, we have a public app called Network Tools, HE Network Tools. There you can actually go and check out the network interfaces. I think the text is a little bossed up here, but essentially you can go and look at the network interfaces, and you will find IPv6 addresses. So that's good. There is fairly good deployment of V6 on networks, on the 4G and 5G networks, thanks to initiative by Jio and later follow up by Airtel and Vodafone. How can you test V6 on the other side, which is with the content? For content, that is the websites to have V6 support, ideally DNS should support V6, and the web server should support V6. This is where it gets tricky. I've come across many people who would assume that V6 support is there, but it's just the support on the either on the web layer and missing on the DNS layer, or just on the DNS layer, maybe missing on the web layer, or maybe there in the web layer only for port 80 rather than for port 80 and 443. So you can use something like dig plus trace, which dig is the tool in the Linux to do the resolution. When you use plus trace, you use the internal resolution, and you can use it with -6, which will essentially force the resolution over IPv6. So here's an example. Again, sorry for the bossed up text. I think we should probably test out projectors in advance. So here I am doing the trace for iitd.ac.in, and unfortunately the last result is iitd.ac.in is not resolvable over IPv6. It always falls back on V4 for the DNS resolution. Similar test in case of web server test. So if I try to connect to iitd.ac.in, it redirects me to home.iitd.ac.in, and that works well over V6. I'm able to do a curl -6 and do -i just to print the headers, and that works. Another site where it works, well, INNOG.net. There it works over V6. Excellent work by the web team. Where it does not work, I had to pick some interesting examples. So our organizers here, ISPI, if I try to connect to their site over V6, it fails. It does not connect. Web server does not listen for V6. Same thing with, say, someone like Nixie. In case of Nixie, it works over HTTP on V6 to reply that you should redirect to HTTPS, and when you redirect to HTTPS, it does not connect on V6. So it's important to test. It's important to test V6 support. A lot of times it's broken. Why are we talking about V6? Why it's important? Well, it's important because it solves the limitation of IPv4 addresses. As many here would know, IPv4 addressing was 32 bits, so essentially you can have only 2 to the power 32, which is only 4 billion addresses. This 4 billion is also a bit misleading number because a part of address space is reserved, another part is used for private spacing. So there are many reserved classes in between. So actual usable address space is much lower, and it's not distributed evenly. It's not at all distributed evenly. It's heavily, it's pretty much a political issue on which country and which region got their fair share of v4 addressing and which not. In case of IPv6, you have 2 to the power 128-bit addressing. So this is not, you're not looking at 4 or 5 times number. You are looking at a magnitude higher number. So that's a fairly large number. As per one of the estimate, there are more IPv6 addresses on the earth than number of sand grains. So it's effectively unlimited addressing if done in a right manner. There are way more devices than 429 crores. I'm going to stick to crore now because we are in India. So there are way more devices, than 429 crores. So of course, you need more addresses. Internet users alone are estimated to be 5.16 billion. So that's just the internet users. When you include multiple devices, when you include IoT, multiple devices per user and so on, it becomes another issue. Plus, besides end user, you also have API endpoints, web servers, mail servers, and a lot more things which need IPv6 addresses. Eventually, we would hope to have projectors with IPv6 addresses to get rid of HDMI. So IPv4 allocations are painful. You will end up in spending a lot of time, wasting a lot of time with the v4 allocation if you try to get it now. What's the history for IPv4 exhaustion? Well, IANA, which is part of ICANN, which is the topmost body managing the domains and addresses. So IANA allocated last 2 of the /8s in 2011. Then APNIC was the first RIR. It ran out of addresses somewhere around, in April 2011. That was 12 years ago. RIPE ran, later in 2012, and so on with the LACNIC and ARIN. So out of 5 RIRs, 4 have already ran out of IPv4 addresses at this point of time. You cannot easily get addresses from these RIRs at this point of time. You can get some reused address which has been returned over time, or you can just go to private broker market and get it. So it's all part of the exhaustion pain. So what is still keeping up the internet? How come internet still works despite of IPv4 exhaustion? Are we all using IPv6 at this point of time, just like you saw on your cell phone with the LTE and 5G connections, or no? Well, the answer is it's mix of bunch of things which are still keeping up the internet, and it's very much like a duct tape solution. There is existing unused IPv4 address space which has been returned, that has been shared by brokers, so people are selling, buying, and that sort of thing is going on. Then there is very heavy use of CGNet. CG here refers to carrier grade, so that's carrier grade network address translation, CGNet. There is bit of IPv6 which is helping out with the reducing the load, especially on the CGNet. Then there are smart software which are converting packets from one protocol to other. So things like reverse proxy on the server side of things, where you don't need essentially a v4 address for each server to serve traffic. You can have a v4 and v6 terminating on a proxy, and then can run v6 only in background. As a matter of fact, Facebook does that heavily. So on the 4th part, Facebook internal infra is pretty much all IPv6 only. They ran out of v4 at a much earlier stage. And only their front-end proxy servers are running v4 and v6. Everything else behind is running purely v6 with no v4 fallback. What is NAT, network address translation? I mentioned it briefly. Essentially what it does is you have someone behind a private network going out to the internet. So as they go out towards the internet, NAT would rewrite addresses with the public addresses. This essentially allows you to share limited public IPv4 address with a large number of users. You can do anything like 1:8, 1:16, and so on, and try to extend the life. And it has been good for extending life, and it has also been a problem because it has broken a lot of things. I'll come on to that in next few slides. So what's the issue with netting? If we can just do 1:16, 1:32, can we do an infinite level of NAT? Can we just keep on increasing this ratio of NAT and maybe have all the way to say 100, 200, 300 users behind a single IP? Well, no, because ultimately you hit a theoretical limit, which is you can only have 65,535 ports. Um, these ports are taken by various applications as they connect. So you can have a single application consuming multiple virtual ports when it connects to the outside world. And then you have multiple applications running on each phone. You have multiple phones for each family member. And then you have multiple people behind the same NAT gateway. So you end up in hitting this limit much earlier than, than before. And many of these modern apps have a lot of external embedded things like widgets and all, which further creates additional sessions. So there is this problem in using NAT with respect to that upper cap. It breaks end-to-end connectivity and it pushes for more server-client model. If you speak to developers, you will find the amount of pain they go through just because they cannot have end-to-end connectivity. If you make a WhatsApp call to me right now, there is a high probability if we both are behind IPv4, it might just fall back using a client-server model. So instead of going peer-to-peer, the VoIP call will just fall through one of the servers nearby and further add to the latency, add to the cost of running that infrastructure and that server, just because you cannot have easy punching of holes when you are when multiple users are behind the net. Software developers have found creative ways, so they have mechanisms like NAT traversal, which essentially is something like you create a tunnel, you create a tunnel for outside, you open a packet by sending, you open the NAT table by sending a packet to outside when you know it's going to fail, and then you have the other side to reply back and have some central command server to coordinate for the virtual ports on both sides. So it works, but it's just additional hassle, and it often fails. Those are the times when you find your WhatsApp calls heavily breaking, especially when you are on non IPv6 networks. Netting can only support eyeball-facing ISPs. It's impossible to use that for companies selling servers, virtual machine, content hosting. So for them, netting cannot really extend life. If a company is hosting content, they can extend life somewhat by running proxies and other things. But if the end goal is to sell servers, virtual machines, and so on, which most of these cloud providers are doing, they cannot do that, and hence they have to get IPv4 addresses, and hence you see them buying addresses at a premium rate and IPv4 address price going up really high. It makes it very hard for lawful logging, and this is important, especially in the Indian context, as most of you here would know. As part of running ISP operation, you're supposed to do the CGNAT logging. You're supposed to retain that log. I think it's 3 or 5 years, right? So that 2 years? Okay. So you're required to retain that for 2 years now for every session which everyone is making, and that's quite a lot of data. If you have V6 enabled in there, a large part of traffic by volume will flow over V6, which whether you are supposed to log or not is again another set of problem with IPDIR, but which if you're not supposed to log will save you a lot of storage. So now with that background out of way, what is the status of IPv6 deployment? Well, before looking at the IPv6 deployment, we'll do a quick infrastructure walkthrough so that we are in sync on how modern infrastructure looks like for the internet. Well, you have end user who connects to something like internet cloud, who reaches to some servers running at some fascinating data center. There's a data center next door. I saw that while coming in here. So imagine a building like that, end user getting in there, right? But we cannot use this term internet cloud. That's a term which developers use, right? No offense to developers, but we are ISP, so we are supposed to use a better term. So you further zoom into this internet cloud. It's something like end user would speak to ISP's router. ISP router would speak to some ISP's upstream router. Just to put some names, let's say ISP, any A, B, or C ISP here. ISP's upstream router, you would typically expect large upstream players in India, Airtel, Tata, Jio, Sifi, and so on. They might speak to some transit-free network, who might speak to another transit-free network, who would ultimately reach the content player. These transit-free networks are the one which are transit-free by definition. They have access to full routing table and just by sake of their peerings. And essentially all the addresses on the internet are their direct or customers of their peers. So direct or indirect customers. So that's how the infrastructure is like, and they'll ultimately reach the content player. But wait, there is another thing which is internet exchanges. So in many cases, This sort of infrastructure is used for sending traffic at long haul distances, but for high volume localized traffic, you would typically have internet exchanges where ISP's router would connect directly to the content player somewhere in the data center, and both would be sitting on the same layer 2 switch, setting up either bilateral BGP sessions or exchanging routes through a route server multilaterally. Now, this further changes because as traffic grew on the internet, content player realized it makes more sense to just add local caches. If the local caches are sitting locally, and there is a lot more repetitive content, as you would realize, majority of people watch same set of content which can be sitting on the same network. So you can even have the content sitting right on the ISP's router at your ISP's NOC, and they may not even be required to go out except for the first time to do the cache pull. Once that pre-filled in the cache, you have that sitting in the cache. So that's the modern infrastructure like purely on the layer 3 side of things. I have skipped the bilateral BGP sessions here, but of course you can have bilateral sessions over exchange, or you can have over PNIs. So end user speaks to the local home device, speaks to the ISP router, then ISP router would have multiple ways to reach the content ultimately. Okay, sure. Thanks. I'll try to wrap up in 5 minutes. So everything here in this picture needs to speak IPv6. You cannot really have any device skipping v6. There are ways to skip v6 by having tunnels and other things, but ideally in production network you would expect all these chains, all these layer 3 devices, and this is much more simplified model. In realistic case, you would have bunch of routers at ISP, bunch of layer 3 switches, further adding to the complexity. You would have bunch of other upstreams and peering links. So all these links ultimately have to be dual stacked for v6 to work. This is what adds up to the complication. So all the L3 devices need to speak, all the core links, upstream links, peering links, IXP's links, everything should be dual stacked in order to make things work. Why I say dual stack and not v6 only? Because you still need to maintain the support for v4, because there has to be a path for migration instead of just dumping the older protocol. You'll still be running IPv4 or support for IPv4 for quite significant amount of time. Web servers, mail servers, NMS, DNS, you can imagine all these things ultimately have to support v6. So now finally on the status of deployment with that understanding in place, let's break out the status of deployment in broadly in these categories: transit-free networks, large Indian ISPs, DNS hierarchy, content networks, and the eyeball networks. So transit-free networks are the ones which form the internet glue and ensure that internet is reachable. At this point of time, almost all of them have all the peering links dual stacked in between, except maybe certain exceptions. Not going to discuss those exceptions here. Large Indian ISPs, almost all of them support v6 at this point of time, and almost all of them have dual stacked their v6 connectivity in between. As far as I can see, core links between the operators seem to be dual stacked, and there seems to be a fair amount of traffic in there. You can find that in the forwarding table for these ISPs. DNS hierarchy. So going through the DNS hierarchy, root DNS, check, there is good support for that. .com, .net, org, .in, all the popular domains you can think of, whether it's GTLD or CCTLD, they support IPv6, and most of the resolution happens over v6 in that case. Good. Auth DNS of the domains, high uncheck. I don't have percentage with me here, but I think it's extremely low. Probably less than 10% of the authoritative DNS unfortunately supports v6 at this point of time. Majority of auth DNS is still heavily on v4, and this includes iitd.ac.in unfortunately as well. So DNS hierarchy, the last part is the pain part, and keep in mind the part before the last part is heavily centralized, so it's easy to roll out v6 in there. The last part is heavily decentralized, so to get v6 deployed there is much harder. Content network, well, yes, for many with the high volume traffic, no for many of them, it's a mixed case. There are many popular cases including YouTube, Facebook, Akamai, Netflix, high traffic volume, heavily consumed content, all that supports v6. But at the same time, there are fair amount of popular stuff including twitter.com, including GitHub, they don't support v6 yet. They have their own use cases for, they have their own pain cases for not supporting that. We'll discuss that in a minute. And eyeball networks, yes and no. With eyeball networks, I mean the end ISP where the eyeballs are sitting. Again, it's a mixed case. So here's the stat, the popular Apinic stat. So 76.78% of India supports V6, that's what they say. The way Apinic detects it, it's important to understand that to get the realistic idea out from these stats. Apinic would serve certain content, essentially a hidden image, through Google Ad with a V4 only URL, with a V6 only URL, and with a dual stack URL, and then would measure how you are connecting as an end network. Are your users connecting only over V4? Then they will mark that, hey, V6 is missing here. Are your users trying to connect over V6 and it's failing? Then it's going to say V6 is supported, but it's not being preferred for some reason, mostly due to bad routing adding to the latency or broken deployment. And in third case, it would expect that if dual stack exists and end user is connecting over V6, it would mark it that way. So at this point of time, 76% of that measured by the sample size is V6. Does it mean 76% of end users get V6? Well, not exactly, because it's heavily biased because of the mobile data. So of course for Jio it's very high, 97% or something, Bharti Airtel 90% plus, Vodafone I think 83% or something. So for the mobile operators, except for BSNL and MTNL, it's extremely high by that volume. But on the fixed line, it's almost non-existent. On fixed line, as far as you go through this data, you'll only find deployment with Jio, which again is hard to differentiate because they use the same AS number on the mobile and fixed line. And on Airtel, because Airtel uses a different ASN, so Airtel is something like 30 or 40%, and 20, 30% somewhere in that range with the BSNL. But beyond that point, it's almost non-existent. It's almost missing. Whether you go to Railtel, Alliance, ACT, and so on, it's almost, it's less than 5% in majority of these cases. So deployment is actually very, very poor once you look at the ISPs. What about the IIT Delhi network? Well, IIT Delhi shows something like 17% of the users connect over V6 as per the Apinic stats. Now, one problem with these stats is it's using the Google Ad mechanism. So if IIT Delhi's users are connecting over a browser with something like say uBlock or an ad blocker with say Brave, then it won't show up in the data because it will essentially block that URL. So the percentage seems lower. It's hard to know the exact number unless you use some other mechanism to trigger end users to connect over V6 and find that out. How much of traffic will go over IPv6? I think I should finish in 2 minutes. How much of traffic will go over IPv6 once enabled? Well, again, it depends on who you are and where a majority of the communication is flowing. So for the eyeball network at this point of time, you should be able to get anywhere from 70 to 80% traffic by volume, not by individual IPs flowing over V6 once you enable it, because large part of your retail eyeball traffic would be concentrated on these certain 5 or 10 providers. I think there was some stats produced earlier in INNOG which said something like top 15 ASNs are responsible for 90% plus traffic at this point of time. So as long as out of those 15, 10 or 12 are supporting V6, you'll see a very high volume of traffic flowing over V6 as an eyeball player. If you're offering commercial network with leased lines serving business users, you'll see much lower traffic because most of those users won't be accessing YouTube or Facebook in the office environment, and they'll be connecting to certain specific servers or apps which have to be enabled with V6, which of course is lacking in broad sense. For the data center and cloud players, if majority of users are coming from mobiles, then a lot of traffic will come from V6, probably anywhere from 80, 90%. But if end users are accessing things over V4, it would be again much, much lower. So this part on how much traffic goes over V6 is very confusing. It varies all the way from 70 to 80% to somewhere like 5 or 10% on the other end of the spectrum because of this high difference in the behavior of mobile operators versus the fixed line operators. Miscellaneous note, ideally the maximum impact is where IPv6 can help by reducing CGNet load. So if you are planning to deploy V6, you can probably start focusing on reducing the CGNet load first rather than deploying on internally first. If your devices are communicating internally with private IPv4 addresses, ideally you should get V6, but that should not be the part of the priority. It would have very low return because there is no netting happening in the private internal communications. Happy eyeball that helps significantly in reducing the fear of broken V6. This is a standard which ensures that if when packets are sent over V4 and V6, and if the difference is significantly higher in V6, it will just fall back to V4. And Happy Eyeballs is supported in iPhone. It's not supported in Android yet. There's a very good post by Reddit where when they enabled IPv6 recently, they had all sort of issues where ISPs with broken IPv6 were trying to connect, end users on those broken networks were trying to connect over V6, and the fallback was happening in literally in multiple seconds rather than milliseconds, and was breaking their app, and it took them really long time to figure it out and ultimately just remove V6. So Happy Eyeballs ultimately is going to help that problem once it is there on all the popular platforms. It's less of a technology problem and more of a business challenge. I'm going to steal the words of Mr. Jeff Houston from Epinic here. He often cites the example of Jio and Airtel in his talks, stating these networks cannot really run without V6, and hence there was a clear business case to deploy V6. Once network operator present in this room hit that same business case where CGNet is more expensive to run, we'll see a very heavy deployment of V6 happening. That's about it. Any questions? No questions, I guess. Right, thank you. Yes. Well, sorry, say it again. I haven't seen that running in production for a while, so no comments. However, at this point of time, you'll see mobile operators moving away from dual stack to 464 XLAT from some time. So Jio recently with the 5G started with the 464 XLAT. So if you are right now on Jio on 5G, you will find that you have no V4 on the access network at all. You'll find a virtual network interface on the phone, which is translating V4 packets into V6. So on the access, it's V6 only, pure V6. And then from CGNet gateways beyond, it's of course the regular V4 and V6. So 6P, no comments on that. Have yet to see large deployments.
Thank you so much, sir. I would now be requesting Mr. Rajesh Charya, sir, to kindly felicitate our speaker, Mr. Anurag Bhatia. Can we have a great round of applause, please? I would also like to invite on stage Mr. Ramesh R. Chandra from Reliance Jio Infocom to please come on stage, and I request sir to kindly felicitate him. Can we have a great round of applause, please? And with that, we have finally reached our concluding session for the day. I now invite on stage Mr. Ronak Maheshwari from Extreme IX to conduct the peering personals. Can we have a great round of applause, please?
So, guys, while we set this up, all those who have sent me slides for peering personals can please come over here. Since there's no one from Nixie here, I would like to proceed further.
Thank you, Ranak. So, my name is Ajay Kumar, working with DKIX Intervia Internet Services. We run the Internet Exchange services in India. We provide the peering service as well as the cloud connectivity service. So, right now in India, we have the 4 exchanges, DKIX Mumbai, DKIX Delhi, DKIX Chennai, and DKIX Kolkata. So, we started with the DKIX Mumbai. So, around 9 data center we are there, and overall networks 594. At Mumbai we have the 457. At Delhi we have 80 networks, and Chennai 45. Kolkata 10 networks. We support the route server. We use the bird routing server. And we are also available at 17 more data center through Lightstorm. We have Sudhir Kundar as well as me here to discuss anything if you want. Thank you.
Hey, hi everyone, this is Priyam from Akamai. We have 2 peering ASNs, 20940 I'll start with. The traffic profile is content. Traffic volume that we have witnessed of recent has been 250 plus Tbps. The peering policy is open, and we have 9,000 plus IPv4 prefixes and 2,000 IPv6 prefixes. We have 180 plus public IXs for peering, and the details you would be finding in the peering DB entry. We also have one peering ASN that we basically use for DDoS mitigation. It's 32787, which was formerly Prolexic. So the traffic volume is variable, and we have selective peering policy. We have few scrubbing centers off late deployed, so yeah, we are encouraging for more and more peering. We have 5,000 IPv4 prefixes and 500 IPv6 prefixes. We are growing, and we are in APJ amongst Auckland, Chennai, Hong Kong, Mumbai, and over 40 plus IXs across APJ. And the peering DB entry is updated. So you may reach out to peering@akamai.com or to my email ID, which is p.abhishay@akamai.com for any peering inquiries. Thanks.
So we, as I said earlier in my presentation, so we are now present in India in all major data center through Lightstorm. So our ASN is 45274. So we have eyeball and some content, around 600 Gbps of traffic. Peering policy is open. At present, we are present in Delhi, Noida, and Mumbai. So our peering DB entry is peeringdb.com/net/30440. And if you want to contact us for peering, so my colleague Ghanshyam Rao, Sarul Saiju, please address to them and send an email to peering@worldlink.com.np. I have one more. So I have already given a brief about NPIX. So we are present in 3 different locations in Kathmandu. We have peak traffic around 2.5 gig in NPX PTS, then around 10 gig in NPX JWL, and 15 Gbps in others. So altogether we have around 25 Gbps. We have route server. And we have peering DB entry also, peering DB/IX241 for NPX PTS, and peeringdb.com/IX168 at NPX JWL. If you want to contact us for peering, please connect with Rupesh Shrestha at rupesh@npax.net.np. And I really want to request, please, all CDN operators, please come to our IX and please peer and help us to reduce our IP transit costs. Thank you so much.
Good evening, everyone. We are controllers data centers in Pioneer Labs. Our ASN is 18229. Peak traffic volume is 200 Gbps. Majority of the traffic is eyeball traffic, and our peering policy is open. Peering locations are Mumbai, Hyderabad, Bangalore, Noida, Lucknow, and Patna. You can find us at peering DB entry mentioned in the slide. And for any peering related information, you can contact myself, which is Vipul Kumar, or Vivin Varghese. As far as our data center facility goes, we are present in Mumbai, Hyderabad, Noida, Bangalore, Lucknow, and Patna. IXP present in our data center are, in majority of our data center, Extreme IX and Nexi are present. And approximately 50 plus ASNs are present in Mumbai, 70 plus are in Hyderabad, similarly 20 plus in Bangalore and Noida, and 10 plus and 5 plus each in Lucknow and Patna. Thank you very much.
Good afternoon, everyone. I'm Dibya. I'm with PCS. We are AS42, AS30 at 56. We do basically DNS anycasting as well as operate route collectors for collecting the routing data. We peer with open peering policy, and we are present at 264 IX globally. Our peering DB entries are AS42 or AS3 at 56.peeringdb.com. If you'd like to host a PCS node at Exchange Point or peer with PCS, then you can contact me directly or write us at peering@pcs.net. Thank you.
Hello everyone, I am Nihit from Netflix ES number 2906. We have an open peering policy in India. We are available at Mumbai, Delhi and Chennai. If you are interested in knowing about our CDN infrastructure, which is Open Connect or Netflix Open Connect program, here is our website, openconnect.netflix.com. For peering request, you can raise a request to us and we'll reach out to you. And if you are interested in setting up caching servers or Open Connect appliances in your network, that information is also available on our Open Connect website. You can raise a request to us. Thank you.
And last but not the least, Extreme IX.
So, hello everyone, I am Rohit from Extreme. First of all, I want to thank all of you, all the peering community, that we crossed 2 Tbps traffic in our exchange. We started Extreme IX in 2016, and by today we are available in 6 cities: Delhi, Mumbai, Chennai, Hyderabad, Kolkata, and Bangalore. We are having 36 live POP locations on these 6 cities. You can find breakup in my slides. And also we are having almost 600 customers connected in these POP locations. The details are available in the slide also. In this year, we are planning to live few more cities and 10 more POPs locations. Also, as our next plan, we are launching our self platform as a service. You can find more details in www.extremeport.in. Also, if you have any queries, you can email us on sales@extreme.net. Thank you, and thanks for your time.
There's a surprise for all of you. There is a recorded video from Mr. Anil Jain, who is CEO of INNOG6, and he is going to talk about in this recorded video of INNOG6's plans and growth. Just wait for a couple of minutes while we load the video.
Namaskar friends. Greetings from INNOG6. First of all, my apology for not being able to present in person among all of you. Although I would like that all the INNOG fraternity is belonging to us, and we should be present whenever you meet. Anyway, whenever in future we'll get an opportunity, we would like to catch up again. Happy with the help of all of you. I'm very happy to inform you that INNOG6 has come out as the biggest internet exchange point globally. Today when I'm talking, INNOG6 has 66 internet exchange which are spread over in the country, and we hope that this number will continue to grow with the support of ISP friends, CDNs, and internet users. It is something very important to inform you that the growth rate which NIXI is registering, whether in terms of ISP onboarding with NIXI Exchange, CDNs onboarding with us, or the traffic which is getting registered, is phenomenal. We have become a member of Asia Pacific Internet Exchange Forum, and we have also become member of European Internet Exchange Forum. Wherever NIXI representative is there, people are asking that how NIXI is able to grow so fast. I'm really thankful for all of you and constant support which we are getting. Now we want to take up internet exchange as a concept to the next level. And next level is to provide and to construct a data superhighway for the country. So when we are talking about data superhighway, it means the aim and objective is that citizens who are residing in the remotest corner of India, right now they are not able to take advantage of internet and facilities which are related to internet. For example, in case somebody is sick, traveling all the way to a district center is a pain point for rural folks. Very few young boys and girls from rural area are able to get education in high quality institutes, engineering college, law universities, medical college, architectural colleges, or you name anyone. The reason is that they are not able to contact these big institutes through internet. They are not able to, so in one word we can all say that the facilities which are available to metro cities and bigger cities of India, those facilities are not available to either the semi-urban areas or rural areas. So what we can do? What you and me as a community can do? And this thought process is going on for last 1.5 years in NIXI. So what we are contemplating to build up a system, a internet exchange, in which not only ISPs and CDNs can peer, but universities can peer, big banks can peer, hospitals can peer, hotels can peer. Think about any big private or government institutes whose data are important for day-to-day life functioning of you and me and any citizen of this country. Now when this data, when these people come together, then it is also not simple because everybody has their own computing system. All these institutes are available with their own software and their APIs. So the difficulty is not only to scale up the present internet exchange, but also to ensure that multiple interfaces are able to come together and operate together. And think about this, that if we are able to connect your internet exchanges in such a fashion, and you are able to take last leg of internet exchanges to your rural areas, then you can think that we as a community is able to contribute to inclusive growth of India. Inclusive growth in terms of medical benefits, inclusive growth in terms of agriculture knowledge, inclusive growth in terms of education, inclusive growth in terms of financial availability, for example, loans or anything. So if we are able to bring all these aspects together and the data flow from one end to all, from the cities to the remotest end in the rural area, then the real benefit of the growth of GDP, whatever we are able to see today, can be enjoyed equally by all of us. This is not a simple planning, in the sense that you just build up a internet exchange, connect internet exchanges with each other, start flowing the data. So a lot of planning with respect to capacity, augmentation of capacity, interoperability of various systems, as well as the most important is the security aspect. We have to ensure that whatever data is passing through internet exchanges, it should not it should not get prey to those cyber attackers who are growing day by day. So multifaceted technological innovations, I must say, is required to ensure that this concept of data superhighway takes a reality. One more thing which I want to also inform all of you is that it is not only that we will be transmitting data from one end to another end, but think of when such a massive network is built up across the country. Huge number of applications which we are not able to think today will be available to all of us, will be available to OEMs, and will also be available to the citizens of this country. Unique concept, different people across the globe are experimenting this at various levels. But there is no system or there is no country which we can take as an example and borrow this concept from them. But at the same time, even if this facility is available in some countries, maybe Brazil, maybe Sri Lanka, maybe UK, but whether that particular thing will be suitable to us may not be. What we have seen over the years, that if we borrow a technology or a system from outside, it don't work exactly as it is working in those part of the world. So I think time has come when we have to invest in R&D. We have to invest in capital for establishing such a massive network. We have to ensure that there is a full security of data, and I think it is important that even the software developers at the user end are required, because huge amount of data will be available and a user has to segregate that data using a menu. So this huge amount of data which will be available to users and also to all of us requires to be analyzed, filtered and make intelligent as per the applications which are desired by the end user. Now this means that there will be lot of job creations, lot of innovations at local level, and definitely this will improve overall IT industry in those areas. So I personally feel that it is a promising area where all of you, all of us can work together and contribute. These are initial thoughts, dear friends, and I request whoever want to contribute in this, you are most welcome. Now on this occasion, I would like to inform you that Government of India through INNOG6 is organizing the first global UA Day celebration at New Delhi on 27th and 28th of March. On this day, this is being celebrated with the support of ICANN and with the support of UASG, Universal Acceptance Specialist Group under ICANN. So on these 2 days, in addition to the leadership from India, including Honorable Minister for Communication, Railways and Electronic and IT, Shri Ashwini Vaishnav ji, MOS Mighty Shri Rajiv Chandrasekhar ji, Secretary Mighty Shri Alkesh Sharma ji, and other senior officers from various departments. We are expected to get Chair ICANN, Dr. Tripti Sinha, MD and CEO President and CEO ICANN, Sally,